This meeting is being recorded.
Hi, Chris, I think you're up. Chris, are you muted? Federica, can you hear me?
Yes, I can hear you. I can hear you.
I cannot hear Chris. I don't know if Chris...
No. Let me ping him.
Thanks, guys, for saying you can hear me. I see that in the Q&A. We just can't hear Chris, who's our first person to kick off the event. Maybe he froze. Federica, could you stop the recording and we can start it again because there's no reason to,
Okay.
Oh, he just blue screened. Okay. He just blue screened. He's going to restart. Okay. You don't need to pause it. You can stop the recording because what will happen is when you stop the recording and start a new one, it'll create a second file. So you can actually stop the recording. Chris actually had a blue screen on his laptop. So I will step in if you want. If I don't have the slides that Chris was going to show, but I think it's just like 2 or 3 slides. So Federica, do you have those?
I can. Yeah, I have them. I will share mine. Okay, so that you can. And there is the agenda, by the way. Okay.
Okay. So you can start the recording, and then I'll pretend I'm Chris.
Okay.
Is it recording? No.
This meeting is being recorded.
Okay, welcome everybody. While Chris recovers from a blue screen, I will step in and do the best I can to tell you what today and the next 4 days is going to be all about. So first, let me say welcome and thank you all for spending a few hours of your day with us today and over the next few days. It is our sincere wish that we give you useful information about how to get the most out of all of the solutions around an ACI fabric. We assume that most of you have been exposed, are thinking of ACI, or maybe even have ACI, but maybe haven't sort of unleashed the full power of it. We really are happy to show you just how easy it is to start realizing those benefits. So if you could please move to the next slide, Federica.
Just a moment.
No problem.
Okay, I'm sharing my mind because
you're sharing your screen. Okay.
Yeah.
I see. Okay, no worries. We'll see all of your detailed emails. Okay. There we go.
Okay.
Got it. Okay. So as I mentioned, we're gonna do 3 hours each across each of the next 4 days. I think sometimes longer on WebEx can be somewhat exhausting. So we will be short, sharp, and to the point. And as I said, it is our goal, our wish to give you useful information to take away. So this won't really be about marketing or any kind of thing like that. This is more about operations, configuration, best practices, useful things that will allow you to get the most out of your ACI fabric. So today, Chris Pagan and I, when he rejoins, are going to bring up an ACI fabric from scratch, from zero, from factory default. What do I do? What does it look like? What are some of the best practices? And we'll do all of that in 3 hours. So this will be an interesting challenge for us, but I think it's fully within our capabilities. Tomorrow, we will be joined, we're joined today by a few of our colleagues, but Max Ardica and myself will take what we build on today and extend that to a few more interesting technologies, namely multi-pod and multi-site as 2 possible solutions for extending your ACI fabric to, let's say, different geographical locations. In day number 3, you by then will be tired of hearing my voice. So actually, we will have some of our colleagues, I think Domenico D'Astoli will be talking about what can we do with ACI in the cloud and how do we integrate with container infrastructure as well. Both of those things are fully possible within ACI. And then on the very last day, on Thursday, we will talk about, okay, I've got my fabric, I've got everything set up and connected. what do I do on day 2? What are some of the tools and information that I can gather, telemetry, analysis? How can I optimize my network? How can I troubleshoot my network? How can I be aware of the state of my network at any given point in a very intelligent and correlated fashion? And we will be joined by our colleague, Matthias Wessendorf, who will be talking about all of the tooling that we're doing around day 2 operations. You may have heard about some things called Nexus Dashboard. And all of this stuff will be, based on using the technology and how it works. So could you please go to the next slide? So housekeeping notes, I think none of us are strangers to WebEx, but because we're using something called Event Center in WebEx, it's important that I think we'll try to keep people muted because otherwise we'll get a bunch of background noise and ruin the experience. But if you do have a question, we have the Q&A panel. I think, again, this is probably something you're very familiar with because I see people already using it. But if you click in your WebEx UI, you'll see a Q&A panel. You can ask any questions you want. We are joined by a number of Cisco colleagues, very knowledgeable Cisco colleagues, and they can answer just about any question that you can throw at them around today's topic. Okay, and yeah, any questions around there? Yeah, I think Q&A is the way to go. Is there a next slide?
No, there isn't.
No, that's
I
the
have
last.
just to add one thing. Yeah, I have just to add one thing. At the end of this session, there will be a survey. So great if you can let us know what do you think about this session, because we want to improve.
Okay.
That's it on my side.
All right. So I think Chris has rejoined us. Chris, if you're here, if you wanna kick it off, I've done the housekeeping.
Yeah,
WebEx
I'll
stuff,
try.
and now it's over to you.
Yeah. All right. Thanks. Let me just find my marbles. My computer just literally had a blue screen of death as I guess we switched from the training event from the live one. I sent you a picture of the screen anyway.
Yeah.
All right. Let me just find the prezo because of course I just came back from that crash.
And you have Windows updates. That's always an impressive combination.
Yeah. Of course. Yeah. My PC crashed and then went into a Windows update, which is just beautiful. So I assume
I've done these, Chris. Yeah, I've done these.
I'm sorry. Yeah, you've done. Wait. Let me just share now. Okay. So that the prezo mode should be coming up.
Yeah, coming up now. Yeah, you're looking good.
Okay, so I missed the part that you guys covered. I guess you covered the agenda, I suppose, already.
Yes,
right?
I did.
So,
yeah, we're good.
Okay, and you set the stage for what we're doing now, or am I doing this now, or?
Well, very briefly, but if you want to add some color, yeah.
Okay, all right. So thank you everyone for being here. I'm sorry for the little interruption. My computer decided not to play game. So I'm Chris Pagan. I'm a distinguished engineer in the data center group at Cisco. I lead the global technical marketing engineering team for ACI. And I'm joined here by Joe, not distinguished engineer. So Joe is a member of the TME/product marketing team in the organization as well. So what we're going to do this week is essentially take you through as many demos as possible and as few slides as we can, and really give you a sense of how to make the best out of your ACI fabric. So meaning we'll show you how we configure a fabric from zero. No cheating, everything is live. We'll have workloads communicating over the fabric. We'll have a link to an external router. We'll establish external connectivity. We'll bring in virtual machines in the system. We'll explore automation options as well for today. And then as the event unfolds the rest of the week, we'll build on top of what we've done. So today is really, we're going to be looking at a super clean slate fabric and bring it to a fully operational state where you could literally deploy production workloads on top of that. And then tomorrow, there's going to be how to extend that fabric to multi-pod, multi-site, and we'll cover integration with containers in the cloud, and then we'll take a look at day 2. But today, right now, the focus is essentially taking a fresh fabric out of its boxes and making it fully operational. So we are assuming that you know already what ACI is. In other words, I'm not gonna spend time discussing the value proposition, the business benefits, the competitive advantages, and I assume you've done some amount of due diligence and you are at a stage where you have just deployed a fabric or you are about to deploy a fabric. I also assume to a certain extent that you know some of the basic constructs in ACI, like tenants, endpoint groups. We'll go quite slow anyway. So the idea is not to just make you go through as much material as possible, but the idea is really to teach you how we do things and also convey the sense that ACI is simple when you do the things the right way. So there's a few things that I'm going to assume are understood. If that's not the case, you have access to a panel of extremely high quality. So I'm joined with several members of the business unit and the field, and we're here to answer questions you might have in the Q&A panel. All right, so with that behind us, the goal is again to show you how you can go from zero to fully functional, to a fully functional ACI fabric. And it's going to take much less than 3 hours because we should have plenty of room at the end for automation and exploring how the fabric actually works behind the scenes. So what we're going to do now is the initial fabric setup. So Joe has prepared a lab, a physical lab. So this is not a simulator. This is a proper fabric, which is ready to be configured. So right now it's just sitting idle, waiting for keyboard input. We will cover, before we do that, a few housekeeping items. In other words, what we believe are things you need to look out for before you set off to deploy your fabric. And once that's behind us, Joe will then continue connecting things to the fabric. So virtual machine, bare metal servers, will secure the workloads that are connected to the fabric. And then we'll extend connectivity of those workloads to the outside world using what we call an L3 out. So we'll use a border leaf and then we'll get out. And at that point, I'll take back control of the session and explore automation with you guys. So here's what we believe you should have before you set foot in the data center. So of course, now you've received your fabric, you've unboxed it, you've cabled it. So we assume you know how to cable the system. So leaves connect to the spine and the controllers connects to the leaves. So once you've done that, what you should have is at least 6 routable IP addresses. When I say routable, it means that they should just be accessible from your management station or wherever you see fit, but they should be accessible from at least the computer or the computers that are going to manage your fabric. So that's why we call them routable. You don't need public IP addresses, they just need to be internally routable. Now, why 6? Well, because a fully functional ACI cluster has 3 controllers minimum, right? So each controller is going to need 1 out-of-band IP address. That out-of-band IP address is used when you SSH to the box or if you HTTPS to the user interface. So without that, it's going to be very, very difficult to do anything on ACI. You have to go on the console and start typing CLI commands, and that completely defeats the purpose. So you really should set aside 3 IP addresses for the APICs themselves. Now, the APICs themselves, they are appliances. They're pre-configured by Cisco. They're loaded with the right hardware configuration, and the software is already pre-installed. Nevertheless, underneath those APICs, there is a C-series server, which means that you can do off-band or off-board or lights-out management of the system. And we call that the CIMC, the Cisco Integrated Management Controller. So the APIC appliance has essentially 2 distinct processor complexes. There is one for managing the board itself, and of course there is a pair of physical Intel sockets for running the APIC application itself. The CIMC uses an IP address as well. So each APIC will need 1 IP for the CIMC. What do you use the CIMC for? Well, for the very initial setup. So the CIMC is where the very first setup questions are going to be displayed for you to answer. So when you power on an APIC for the first time, you have to be either physically in front of the console with a VGA monitor, or what you can do is if you have a DHCP, for example, you can hand out an IP address to the CIMC, and then you can SSH into the CIMC. At that point, redirect the console into the screen. But you're going to need to have an IP address for the CIMC. That's why we say 6. So long paragraph to justify why 6 IP address, but we very, very, very much recommend that you set aside 6 routable IP addresses. The next component that is very heavily recommended is an NTP server to synchronize all of the operations inside the fabric. So everybody should have the same external clock source. And NTP is a great way to do that. So we heavily recommend it. The next bit that through experience we also recommend that you collect are the serial numbers of every single switch in your infrastructure. The serial numbers, they're located on the boxes themselves. There's a little pull tab at the back of the system, and you pull it out and you will see the serial number. What I recommend, and this is what I do personally, if I receive new equipment that I'm going to stage and then install in the lab, I take a picture on my smartphone of the equipment, and then in a CMDB, it's just a spreadsheet that I have, I assign a name for that serial number. So in other words, for example, if I receive a 93 GCFX leaf, I'm going to say, oh, the serial number that ends with YZ is going to be leaf 106. So I write that down somewhere. And you'll see why, because the fabric discovery is essentially determined by the serial number of the devices as they appear. So we discover switches on a first come, first serve basis, basically. And so if you don't know where the serial number is located in your data center, you're not sure if you're configuring leaf 1 or leaf 2 or leaf 3 or leaf 4. So we really recommend that you write down the serial numbers and you put a name next to them so you know which device you are configuring. What we then also recommend, it's optional, but again, with experience, it's something that has saved our bacon a few times. It's you should have one out-of-band IP address per leaf and spine. The reason is they're used for multiple reasons. One, you can always SSH into the switches in ACI. You can always go directly to the switches and take a look at whatever you want. You want to look at the state of an interface, you can do that. You can also do it from the controller, of course, but you can also go directly. But more importantly, if you are going to do SNMP, for example, any trap, or if you're going to export syslogs, the switches are responsible for generating their own messages, and they use their own IP stack for that. So if you don't give an IP address, you will not have SNMP traps going out of the switches. Again, there are tweaks you can perform, so you can aggregate all the traps through the APIC, which then becomes a collector. But by default, out of the box, those protocols will use the IP stack of the devices. We also recommend that you have some sort of data storage for backups and images. So SCP, FTP, HTTP, it's all fair game, whatever you prefer. The best is probably a secure system, so SCP would be preferred. It should be outside of the box, of course. You know, the box can store images and configurations, but if you lose the APIC itself, it's much better to have an external repository for that type of data. So that's recommended. And for those of you who've been in the business long enough, you know that when everything else fails, the last thing that will be available to you is a serial console. And I would also strongly recommend that you connect every single console port of your devices to a terminal server and then use reverse telnet to connect to the consoles. As you know, that's usually your lifeline when everything else has gone wrong. Then the next consideration you have to pay attention to is what is called the infrastructure VLAN. So the ACI fabric is a VXLAN overlay, right? So it's self-configures, so you don't need to worry about VTAPs and BGP and route distributions and any of that. It's all, you know, configured automatically on your behalf by the controllers. But for that sort of magic to operate, there is a need for an internal infrastructure addressing plan in the fabric, and that's called the infra VLAN. So between the leaves and the spines, between the controllers and the leaves, there is an infra VLAN, which is used for DHCP, for example, and other protocols. That VLAN is something you need to provide at setup time. And once you choose, that's it. In other words, you cannot change that VLAN once it is configured. Now, in 99% of the cases, you can pick any VLAN you want and you can forget about it, because you will pretty much never extend that VLAN outside the fabric. There are exceptions. The exceptions are when you use integration with OpenStack, with OpenShift, with Kubernetes. So when you do that, you need to extend that VLAN outside of ACI to a host, typically to a Linux system. When you do that, you need to ensure that the VLAN you picked is, one, unique, not used by something else. And two, it has to be compatible with whatever infrastructure sits between the Linux box and the switch. For instance, if you pick 3998, right, that might conflict with the reserved VLAN range in a Nexus 5K or 7K. So you have to be sure that whatever you pick, if you ever have the requirement to extend it outside the fabric, does not clash with a reserved set of VLANs. That's pretty much the only consideration you have to pay attention to in terms of the infra VLAN. You will then have to pick a VTEP pool. VTEP is virtual tunnel endpoint, and that's a term which comes in VXLAN fabrics. Every leaf, in the case of ACI, is a virtual tunnel endpoint, meaning it starts and terminates, so to speak, VXLAN tunnels. And because of that, we need IP addresses to start and terminate the sessions. That's what the VTEP pool is for. The VTEP pool, again, very much like the infra VLAN, stays inside the fabric. So typically, this is not something you need to worry about unless you plan to extend the ACI fabric to multiple pods. So if you use multi-pod, which we'll be talking about tomorrow, then the VTEP IPs have to be routable inside your organization. You can use a VRF for that. So even if you were to pick a range that clashes, there are ways out, but it's probably better if you are thinking about extending the fabric to multiple regional locations with multi-pod, then you should pick a TEP pool which is routable and unique in your organization. And then if you are going to connect ACI to your vCenter or vCenters, because we can connect to a lot of vCenters, you should really have the IP addresses and credentials for vCenter. Right. So what the fabric is going to look like when you have installed and cabled it, it's going to look exactly like this. You're going to have at least one spine, ideally 2 spines in production, and as many leaves as you want. We support up to 500 leaves today with multi-pod, and up to 400 per pod. So it's a very, very scalable fabric. Obviously, we don't have 400 leaves today, so I think we have 3. But 3 and 400 is the same thing from a complexity of configuration standpoint. So that's one of the benefits of ACI, by the way.
And one small correction, Chris. Spine 201 should be spine 201 and spine 202 at the top.
Oh, yes.
I forgot to fix that.
Oh, yes, over here.
Unique,
So the spines
uniquely identifiable. Yeah.
It should be 201 and 202 over there.
Yeah.
Yep. And then what you're going to do is the apex, which are the controllers for the solution. So the apex is purely a management plane function, right? It's not even a control plane function. It's purely management plane. In other words, there is no single packet from users' workloads that crosses the APIC, right? APIC is never responsible for running any data plane function, and it never runs any routing protocol, or it's not involved in running BGP. It does not program flows on anywhere. It simply renders your intent, which is, hey, I would like these workloads to communicate no matter where they are. It's responsible for translating this into JSON and sending it to the leaves, which have what we call doer threads, and the leaves will translate that into machine instructions. But that's all the apex are doing. They're there for monitoring the fabric, receiving alerts and faults and logs, statistics, telemetry, and providing you with the user interface and an entry point into the fabric. So if you want to configure the fabric, you go through the APIX. Strictly management plane. From a physical standpoint, if you deploy Fabric today, you will have APIC M3 or L3 controllers. These are the latest generations of controllers we have. And you will see clearly labeled on the box, there is a label here which will say to Fabric, and you have to use these two interfaces to connect to the leaves like this. So what we do recommend is you use 2 connections per APIC, and you go to different leaves. Also, from a physical placement standpoint, we heavily recommend that you do not put all 3 APICs in the same rack, for the simple reason that if you lose the rack, well, you've lost the cluster. If you lose the cluster, it's typically non-catastrophic. The system will function just fine without the cluster. However, if you lose everything and it's immediately destroyed, and that's a little bit more complex, we can recover, but this is outside the scope of what we're going to do today, which is why we recommend that you split physically the APIX into different racks. All right, and these are the management ports I was talking about for out of band, and this is the CIMC port. You can, by the way, overload the management ports and the CIMC, so you can have a VLAN for the CIMC and another VLAN for management. So if you don't have enough cables, don't worry, you can use a single cable here. That's just fine. Right, that's basically it. Once you've connected everything like as you see here, well, it's time to bring up the CIMC and configure things. And that's exactly what Joe is going to do next. So this is the lab that we're going to be using today. So there is 1 spine. Again, in production, you probably want 2 spines. There are 3 leaves. We have a pair of UCS fabric interconnects with blades behind them. This is where our virtual machines reside. And throughout the session, Joe is going to set that up from 0 to a point where the VMs will be able to securely communicate both internally and externally. So there is a firewall connected to that border leaf, which is going to be talking OSPF with the fabric. And Joe will configure everything as you see here. One note, in this lab, there is a single APIC controller. This is only for lab environments. In production, you have to have 3 APICs. From a configuration standpoint, there is no difference. Once you are done with APIC number 1, you continue with the fabric, as Joe will show you. And when you are done with the entire fabric, then you connect APIC 2 and APIC 3 to the fabric, and you answer the initial setup dialog. And that's all there is to it. The cluster will converge by itself, will check its health, and will tell you if everything is fine. And there is nothing for you to do there. There's no cluster fine-tuning, no file system to mount, nothing. It's all completely automatic. All right, Joe, I think this is where you take over.
Yeah, most definitely. Could you please pass me the ball?
I could, but I'm afraid my computer's going to crash, but I'm going to try.
If not, Federico will force it.
Hold on a second. So I'm stopping the sharing, and I'm giving you the ball, like so, and you should be on your way.
I'm on my way. I'm going to share my entire screen now. That's always a risky proposition, but I've tried to turn off my mail and messaging, so
all right,
we'll do our best. Okay, so let me go in here. Yeah, so right, so I'll take over from here. Thanks, Chris, for the nice setup. So this is my lab, as Chris said, not highly available, but sufficient for our needs because the configuration and interaction doesn't really change. But this is what I have. So I've got, like Chris said, I've got Blade. I've also got a rack server as well, and I've got VMs, I've got bare metal, I've got external things. So we'll go through all of that. By the time we're done, we'll have a functioning fabric where everything can talk to everything else just as we desired. So the first thing I'm going to sort of talk you through is when you connect those APIC management controllers to the fabric, we have to go through what I call sort of a day 0 bootstrap setup script. You have to answer a few questions. And Chris referred to that when we have the VTEP pool and the infra VLAN and things like that. So when you first unbox the APIC and you rack it and connect it to your leaves, how do we initially access the APIC to bootstrap it to work with the ACI fabric? So we have the management controller that Chris mentioned, the SIMC, And out of the box, the SIMC port is configured to use DHCP. So either you connect it to a segment that has a DHCP server and can get an address, or you can connect a physical monitor, keyboard, and mouse directly to the APIC server if you want. But let's be honest, in today's modern world, we want to be remote and lights out. So we can also, if we can get an address somehow on the SIMC, then from there, we can get into the server remotely and answer those questions. But I just kind of wanted to give you the ultimate, where do I start, is we need to get an address somehow on the management controller of the first APIC. And so this is an image of what that looks like. And as you boot up the first APIC, you could break in, if you weren't using DHCP, break in and assign a fixed IP address to SIMC as you desire, right? But we're going to at least need at least that to get started. So we will assume you have already done. So I'm actually going to stop with the slide, and I'm going to show you me logged in to the management controller, the SIMC of my one and only APIC, or in this case, the first APIC in your production cluster. So it's a web interface. It's using HTML5. We have a couple of choices here. We can get into the console of the ACI software running on here by launching a remote KVM, which is standard lights out kind of management. I can click that. It'll open up another window, and I'll have a view of the console. Or something that I like better is I don't always like to launch additional apps. We have something called Serial Over LAN, or SOL. And this is disabled in SIMC by default, but if it's something you might want to consider enabling, is under the compute part, under remote management, you see that there is something called Serial Over LAN, and I've enabled it in my case. What does that allow me to do? Well, effectively, it allows me to SSH into the SIMC, and I'll put inside quotes what most people might consider the same as reverse telnet, up into the console of the software running there. In this case, it's using SSH, so we're calling it Serial Over LAN. So that is actually what I prefer to do. So what I will do is I will SSH into the IP address of the SIMC of my first APIC, which will get me into the CLI of that first APIC. It takes a second to actually log in. So here I am in the hardware of the server itself, but I want to jump up to the application console that's running on top of this. So the command that I type is connect host, and what that does is it brings me up now into the software running. Right now, the software has never been configured. It's fully fresh, new, out of the box. This is exactly what you will see when you set up your first ACI Fabric. So I'm going to go ahead and hit return. And the thing you didn't see is say hit return to begin setup. So it's going to bring up the starting setup utility. Now, usually when network people like us, when we get into a console, what do we normally have this inclination to do is hit return 2 or 3 or 4 times just to get the thing to come up. My recommendation here is don't do that, because effectively there's going to be a series of questions presented. And those questions oftentimes will have a default value. And if you just hit enter, you're accepting the default value, which may not be what you want, right? So in this case, if I hit enter 2 or 3 or 4 times, I just answered the first 3 or 4 questions. Now, the good news is I can go back and change those things at the very end, but it's extra work, and we want to be as efficient as possible. So you can see here, I haven't touched anything except hit enter 1 time, and I get the very first question. Now, what I'm going to do, because after I answer these questions, it's going to take about 3 or 4 minutes for everything to kind of spin up and settle down. I'm going to answer these questions really fast, but while it's spinning up, I'll go back and show you what I answered and explain each of the choices that I made so that you understand where we're going. So a lot of these questions are standard. Things need names, things need numbers. So I'm going to quickly go through, again, answering these questions, but I will come back and explain all of the choices that I made. Normally, you want 3 active APIC controllers in your fabric. In my lab, I only have 1, so I'm going to say 1. Pod ID, I'll explain in a bit. This is not a standby controller. My controller ID, in this case, can only be 1. I'm going to give my APIC a name. Again, normally you would have 3, so 3 unique names. It's going to ask me for an address pool or TEP addresses, and Chris mentioned this as well. It's suggesting a /16. We usually recommend, TACT would recommend that you go with a /16 It doesn't have to be a /16. It can be smaller. I think /19 is the smallest you can go. In my particular lab, I'm happy with this default. So I would just simply hit enter and accept it. It's asking me for an infra VLAN. We need a single infra VLAN that stays inside the fabric, like Chris mentioned, where all of these TEP addresses and things will live. This means I need to dedicate an unused VLAN that is also not a reserve VLAN. And in my lab, I chose 3456 because it's easy for me to remember. But in your lab, you would choose the appropriate VLAN that makes sense for you. I also have a request for some multicast addresses, and again, we'll explain that in a bit, but I'll just accept the defaults here of a /15. I'll explain. We need to put an IP address on the controller itself so we can actually get to the UI or the CLI of APIC itself once it's running. We do support IPv4 and IPv6. In my lab, I am not running IPv6, but I am running IPv4. So I'm going to go ahead and type the IP address of the APIC itself. This will be the IP that I will use and point my web browser to, and something that we'll be using for the rest of today. So I'll put an IP address. It also will ask me for the default gateway, standard stuff, speed and duplex, auto. I mean, we're in 2020. Of course, it should be auto. We need to configure an initial user account, an admin user account, at least to get started. We can, of course, add more accounts later or do different kinds of authentication, TACAX, Radius, LDAP. But in this case, we need at least one account to get started. It's asking, do we want to enable strong passwords? In my lab, I say no. Obviously, you will choose what is best for your security plan, and it's probably yes. So I'm going to go ahead and choose a password for this admin account. And of course, I have to enter it twice, so I make sure that I'm able to get in. Now, again, I went really quickly through that. I'll explain all of the choices that I made in just a minute, but it's offering me one last chance to make any changes before I commit. Now, it's important that we review this and that it's proper and right according to what we need to do, because once you commit this, you cannot go back and change it, right? It's fixed. APIC will spin itself up with this configuration, right? So we need to make sure it's correct. Now, if you made a mistake and it's very early days, like you haven't gone into production yet, yes, there is a way to wipe the fabric and start over, but obviously that is very intrusive, very disruptive. So we want to make sure we get these questions right. So I'm going to say, I don't want to edit the configuration. APIC is going to take those settings now, and it's going to go out and configure all of those basic things that need configuring, spin up authentication services, spin up the web UI, all of those necessary things. Now, this normally takes about, say 3 to 4 minutes to settle down. So I will take the opportunity while that is spinning up to go over in a bit more detail all of those questions that I just answered and the importance of getting them correct. So what you see on the left is basically copy paste of what I just entered. And what you see on the right is sort of my explanation. So let's kind of go through them one by one. So we need to give the fabric a name. The name itself isn't so important, but it's just a name that we can give to this fabric, because as we'll see tomorrow, we can have multiple fabrics. And for humans, names are an easy way for us to differentiate this fabric from that fabric. We need to give the fabric an ID and number. So you'll find that consistently in ACI, things have numbers and names, right? And that's how we can uniquely identify them. In this case, it's my first fabric. I can't really think of any other reason to choose anything other than one. So I always pick one. Maybe others on the panel could give me reasons for picking something other than one in a standalone single ACI fabric. Next question, we asked about the number of active controllers in the fabric. Active controllers means APIC, right? And you know that in a production environment, we have a minimum of 3. If you start to scale up towards that 400, 500 leaf number that Chris mentioned earlier, we have the ability to add more than 3. But in a standard deployment, 3 is probably all you need. The next question is, we need to give this a pod ID. Now, we're not talking about that today, but tomorrow we'll talk about multi-pod. It's the ability to extend your ACI fabric to multiple data centers. And so each of those pods will have numbers. In this case, I always begin with pod 1 if it's my first fabric, and I can't think of any other reason not to choose 1. The next question is this a standby controller? And I said no. Now, what is a standby controller? Well, when we talk about the APICs, we always have what we call, we have that cluster of 3 APICs, right? And in order to make configuration changes to your fabric, you need what's called a quorum. And in this case, a quorum means 2 out of 3 APICs are up and clustered with each other. So if we should lose, say, one APIC, we're still good. We can still read write to the fabric, make changes, do everything that we need. If we lose two APICs, the remaining APIC goes into what's called a read-only mode. Now, your traffic is still forwarding, everything is still working, nothing stops working in your fabric. You've just lost the ability to make changes at the management level at that point. So a way for us to, let's say, provide another dimension of availability with the APICs is we have this notion of a standby controller. Think of it like a sort of a warm standby. So it's a fourth controller. It is, connected to the fabric and it is powered on, but it has not received any configuration and has not joined the cluster. But the fabric is aware that it's sort of sitting there waiting to be called on if the need arises. So let's say, for example, APIC number 3 failed. And rather than opening up, I would open up a TAC case, but let's say TAC decides after a day or two, well, we need to RMA the APIC. And well, that's going to maybe take another day. And then I got to go and unrack the old one, install the new, and I might be without that third APIC for any number of days. And maybe I don't like that. So in this case, what I can do is I could decommission, or the term that we use is decommission the failed APIC. So tell the cluster, look, APIC 3, he's dead. I'm going to decommission the hardware running APIC 3, and I'm going to promote the standby APIC to take over the identity and personality of APIC 3. So that's the new APIC 3. It immediately then joins the cluster, synchronizes, and is participating in the fabric. And that takes a matter of minutes. So you can have that. That's an optional choice, but that's what that question is asking about. Then I need to give the controller itself, APIC, a number. Normally, again, you would have 3 APICs. So the first controller is going to be 1, the second will be 2, and the third will be 3. The controller needs a name. In this case, I named it APIC-AMS because this particular fabric that I'm working with today is sitting in my lab in Amsterdam. So for me to know which APIC I'm working with, I give it sort of a location identifier, but it's any name. You can pick any name that you like. So those are kind of the easy questions. The next 2 questions are the ones we really need to pay special attention to. So the first one is enter address pool for TEP addresses. Chris had mentioned in his intro that we use VXLAN. VXLAN is a tunneling technology, and in order to establish those tunnels, we need IP addresses. So what APIC is saying is, can you just give me a dynamic range of IPs that then I can use for VXLAN purposes whenever I need them? So just give me a pool and I'll take care of the rest for you. And it is suggesting a fairly large network, so 10.0.0/16. Does it have to be 10? No, it can be any address that makes sense for you, obviously addresses that you own or control. And the mask does not have to be 16, although /16 is recommended. /19 is the smallest, I think, that we support. But in this particular case, this TEP pool will live inside the fabric, except in those cases where Chris mentioned where you extend to other things outside the fabric. So we need to make sure it's generally best practices that this subnet does not overlap with other subnets that are in use across your data center. Like I said, Chris said it, generally stays inside the fabric, but just to be sure, TAC recommends pick a unique, dedicated subnet that is not going to be used anywhere else. And so I've chosen the default here, but you would pick whatever is appropriate for you. So that's the first important question. The second question is we need a VLAN that we call the infra VLAN. We need just one, but this VLAN absolutely positively has to be dedicated to ACI. It cannot be used anywhere else inside your data center, and it should not come from a range of what all of the vendors call reserved VLANs. So in the Cisco world, depending on which product you buy, at the top of the range, usually we carve out a couple of dozen reserved VLANs that you're not allowed to use for anything else. Other vendors might have their own reserved range of VLANs, but whatever it is, we need to make sure that it doesn't fall in that reserved range. So for the Cisco world, if we basically looked at any Cisco product that we've ever made, switches, routers, APICs, whatever, and as long as you're between VLAN 1 and 3967, you're okay. Anything above 3967 is going to be reserved in some way within a Cisco environment. Obviously, there's a couple of exceptions there because, like if you look at Catalyst switches, like VLAN 1000 through 1005 is reserved for other purposes. So be aware of those as well. So we need to make sure that that VLAN is dedicated, and that's extremely important. The next question is enter address pool for BD multicast addresses parentheses GIPO. If you're new to ACI, you're probably wondering what's a BD, what's a GIPO? I mean, these are all good questions. So a BD is what's called a bridge domain, and we'll talk about that in a little bit as I configure my fabric. But it's basically, think of it like our SVIs in a routed network, but we'll talk about it more. But BD stands for bridge domain. And the way for us to efficiently flood traffic across an ACI fabric is we don't want to flood. We can flood, but it's not the most efficient way to do it. So what we do within an ACI fabric is we leverage multicast. And we build some multicast trees rooted at the spine. I won't go into too much detail, but suffice it to say, it is a better and more efficient way for us to handle what we call BUM traffic, so broadcast, unknown unicast, and multicast, layer 2 multicast traffic in an efficient way. And in order to build those multicast trees, we need multicast IP addresses range for that purpose. So that's what this question is asking. And by the way, GIPO stands for Group IP Outer in the outer header, but that's just trivia, right? We need to pick a range in the multicast range, and it must be a /15. It cannot be anything else. In fact, if you try to do something that is not a /15, APIC will say, no, that's wrong. You need to enter something correct. So you need to pick something. I've chosen the default. And again, this range, should be dedicated to the purpose of the fabric. So those are the important ones, at least in my opinion, that need to be thought about ahead of time and answered appropriately. Then, of course, the out-of-band IP. This is where we're going to go to right now, and the user account admin, so we can actually log in. So what I'm going to do, and I think my APIC is probably spun up by now. So we can see here, yeah, there's some information here. It's prompting me for a login. What I'm going to do is I am going to open up a web browser, and I am going to type in the IP address of the APIC. Of course, I need to do HTTPS. And we need to accept the self-signed cert because this is the first time that I'm connecting to this brand new APIC. And we'll go ahead and proceed. We will clear this stuff. And it will take a moment for the UI to come up. So this is where I will then log in with the admin account that I set up in the day 0 script. So let's go ahead and do that. You can see I'm running version 502E. It's not the absolute latest version, but it's what I'm running in my particular lab. So this is what happens when you first log in. So you get this welcome screen, and don't just click off of it because there's useful information here. Not only what's new in this version, but there's a number of hot links here about getting started, support, things that you might not have the link handy. Well, APIC will gladly show it to you. I can choose to show this every time I log in or not. It's up to you. But the real button here, the real thing I want to add value is begin this first time setup. So let me go ahead and do the first time setup. So I'm going to go ahead and click that button. Now we added this capabilities to help you quickly get your fabric up, discovered, and some of what I call the basic housekeeping things. So when I say housekeeping, imagine in a legacy environment, every time you bought a switch or a router from Cisco or anybody, you always have to do some basic things the very first time you set it up. Like, I got to get it powered up, cabled. I have to get a management IP, a user account, set up NTP, set up DNS, set up syslog, those things that you have to do every single time, right? You do that anytime you get a new device, and I call that housekeeping. So this is how we do housekeeping in the ACI world. So the first thing that we need to do is we need to, quote unquote, discover the fabric. Because right now we have a fabric that's sitting there undiscovered. And because it's undiscovered, it is therefore unusable. So the first thing we need to do is discover it. So I'm going to click on fabric membership. Now, what is happening here? Well, let me quickly go back to my slides so we can kind of see what's happening in my lab. I've got APIC over here, this green box, connected to leaf 102 and leaf 103 in my particular environment. Right now, these two leaf devices, right, they are sending out LLDP messages, right? Or APIC is sending out LLDP messages saying, hey, who's out there? Who am I connected to? And one of these two leaves, right, is going to respond and show up in this window. This particular, all devices right now are completely unconfigured. There's not a shred of information. So the way that we choose to uniquely identify who is who and which leaf am I actually talking to is by unique serial number. This is why Chris, in his prerequisite, said it's important that we know the serial numbers before we go ahead and rack the devices. So what is this serial number? Well, if I go into my I made a little cheat sheet here, and this is just best practices, where I have all of my leaves, the name I'm going to give my leaf, the number I'm going to give each leaf and spine, and what their serial number is, and an out-of-band IP address. I sort of made these decisions ahead of time. So I wrote them all down because when it comes to configuration, it becomes a matter of copy paste. So if you remember, my serial number was this guy, PL6. And that corresponds to my chosen leaf number 2, right? So right now I'm going to click on the register button and it's going to ask me some questions, right? Every leaf, every spine in an ACI fabric needs two things to get discovered, a number and a name. So this is leaf 2. I have chosen a numbering convention that makes sense for me. You will have to choose a numbering convention that makes sense for you. You can go 4 digits deep, right? So in my environment, I have chosen all of my leaves will be 100 something. All of my spines will be 200 something. And of course, my APIC is always 1, 2, and 3. So I've chosen, that numbering convention. You will choose something that's appropriate for you. And it's a good thing to decide how you're going to name and number things before you actually get started. So I've decided to call this leaf number 2. I don't need to do anything else, and I can go ahead and click submit, right? There's a couple of things to point out. This is going to go through and do a secure exchange. So APIC has a certificate. This leaf has a certificate. They're going to exchange certificates and create a secure connection between each other. APIC will then register this leaf. So this is us telling APIC, hey, this leaf at this serial number is okay to join the fabric. And so it'll go through the process of registering and discovering itself and then securely join the fabric. So we know it's our leaf at this serial number versus, in the old days, it used to be you could walk into a customer's environment with a small switch under your arm or in your bag, go into the conference room and just find an open cable, plug it in. And if you get link up, you're probably on their network, which isn't a very good thing. In this case, with ACI, we are securely acknowledging and purposefully registering known devices into the fabric. Nothing else can join until we actually do this registration process. So what has happened now? So what has happened is, I go back to my image here, is leaf number 2 has just now been discovered and joined the fabric. Because it's now a member of the fabric, leaf number 2 starts sending out LLDP messages to saying, hey, who is connected to me? Who else is out there, right? Now, in the ACI topology, leaves only connect to spines, not to other leaves. We should see the spines show up waiting to be discovered, waiting for us to say it's okay to join the fabric. So that is what we see here. So now I have a serial number, I have a model, I can see its node type is even spine, again, just to make sure I'm on the right track. And of course, just like before, I'll go ahead and click register. Again, it needs a node ID. I've chosen 201 and spine-1 as my name. So I'll go ahead and click submit. Now, it's going to go through that process as well. It's going to securely register the spine. Spine will join the fabric. The spine will then, once discovered, start sending out other LLDP messages, and in which case we should see leaf 101 and leaf 103 show up waiting to securely join the fabric. The other thing that I want to point out here is I mentioned that every node needs a number and a name. So the number, once you commit it and you join that device as that number, you cannot change it, right? That's how we uniquely identify that node in the fabric. The name, on the other hand, can be changed to your desire because it's just a name to make it easy for us as human beings to read and understand what exactly we're working with. So we can see here, down here in the registered box, we can see that the spine itself is going in through a discovery phase. we can see our leaf number 2 is active. We have to wait a moment for the spine to finish securely joining the fabric, and then we should see the other 2 leaf nodes. Now, if something should go wrong and you're thinking, well, it's not discovering, this is where Chris had mentioned that it's a good idea to have a console. So I have a web-based console server, and if I were to click on all of the consoles, you can see I on port number 2 happen to be leaf number 2. Right now, whatever is in port number 1, which is probably leaf 1, there's nothing, right? In fact, if you try to log in, it lets you log in, but there is no configuration. There's nothing you can do. You can't write or do anything. This is a read-only thing, and it's saying, hey, fabric discovery and process, right? You really can't do anything but some basic reboot commands and things like that. There's no configuration. But if you compare that with leaf number 2 has joined the fabric. It asks me actually now to log in because it's securely joined the fabric. Once we register all of the other devices, I think the spine, here's the spine getting registered. All of these things will go back and force a login because now they've securely joined the fabric. So let's go back to APIC. And in fact, we can see that 2 other nodes are wanting to join the fabric based on these serial numbers. Now, again, there's my cheat sheet. Again, helpful to have the serial numbers written down. So F1, as it turns out, is leaf number 1. So that's a good way for me to remember. So I'll give it a number like I have before and a name, and I'll click submit. And I will do the next one for node number 3, which happens to end in N03. I'll register that guy as well. And he is 103, and he is leaf 3. And we will go ahead and let those things register. Now, that's going to take, another 30, 45 seconds for that to do it. So let's go ahead and go and continue, and we'll come back and check on these, but just for sake of time, let's move forward. So there's a couple of other steps that we recommend that you do for quote unquote, housekeeping when you first get started. One of those is setting up BGP route reflectors. So we'll go ahead and click on begin. And I think that spine is still being registered because normally it will show up. But what we have to do here is we have to basically choose an autonomous system number that represents our fabric. Just one number represents the whole fabric. And then we need to select who our route reflectors will be. In an ACI fabric, it's always naturally the spines. So any spines that I have discovered will show up here. If you remember, I only have 1 spine. Normally, you would have 2 show up here. Just for comparison, I only have 1. And I'll go ahead and select that spine and then say save and continue. Why do we need a BGP route reflector within the fabric? Well, when we get closer to the end of today and I configure a routed connection to the internet, I'm going to be using OSPF through what we call a border leaf. Well, I'm going to be sending and receiving routes through that border leaf, but I need the rest of the fabric to know about those routes. And I need the outside networks to know about the subnets that live inside ACI. So the exchange mechanism that we do that so that the whole fabric knows how to reach everything is by using BGP route redistribution. So the spines will learn the routes from the border leaf and then redistribute them to all other leaves and everybody can talk. That's why we need to set that up in the very beginning. The next thing that we need to do is we need to configure out-of-band management. This was something that Chris also mentioned is a good idea. So if I look at my best practice here, the network in red is my out-of-band network. So I included a picture here in the lower right. So every node, every leaf, every spine, every APIC has an out-of-band management port, like an RJ45 or an SFP port on the back of it, right? This is completely out of band, not a front panel port, but dedicated out of band management port. So this is what we recommend you connect all of your leaves and your spines and your apex to. And so this is what I've done in my lab. The reason why we say that is you do have the ability to manage ACI in-band. That's perfectly fine. But it's one of those situations where if things have somehow gone wrong down the road, you don't want to sort of be sawing off the branch of the tree that you're sitting on, because you'll disconnect yourself from managing the network if something should go terribly wrong. Not saying that it will, but anything could, right? So this is why we recommend, out of band is a best practice. So that's what I'm going to do in my fabric. So I'll go ahead and click on review and configure, and all of my nodes should be there. So there's my one spine and my 3 leaves. And I'm just going to click the button that says configure out of band IPs. Now it's basically saying, give me a starting address, right, and a mask, and I'll just go ahead and allocate IP addresses for you, right? So I have chosen in my environment to start at 129.242/24. And if we go back to my cheat sheet, you can see I've already decided that these will be the IP addresses out of band for each of my nodes. Now, notice I go 242, 243, 244, 247. Let's go back to APIC. And we can see, might be hard to see on the screen, but my spine number 1 is the wrong IP. It's 245. So what do I do? Well, it does, the wizard is graceful. I can just click into that node and pick the IP address that makes sense for me. Don't know why it's not. 247. It wasn't ever making me type the gateway before. Oh, I'm sorry, human error. I should have answered this question before. Is starting range, gateway. There you go. The wizard filled it in for me. And now I can successfully change that and say update. These will be the IP addresses that the wizard will set for me. You can see down here at the bottom, APIC is already configured, and I can say save and continue and move on. So there's a couple more things that we want to do for housekeeping. We want to add DNS and NTP. Remember, Chris said that those are something that are useful to set up. So we'll go ahead and click that, and we'll just do some of the basic, giving it an IP address of a DNS server. And you should be impressed by my memory. I've typed this in my lab 1,000 times. So that's my DNS server within Cisco, and I can set a search domain. I can say this is default, or in this case up here, preferred. I can add more than one DNS server and more than one DNS domain, of course, to your heart's content. So that's all I need for DNS, so we'll click that. Now let's go down to NTP servers. It's the same kind of thing. So I want to set my time zone. And if you remember, this is in Amsterdam. So alphabetically, that's good because it's the first in the European time zone by name. So it has to be in that format, Europe/Amsterdam. And then, of course, the IP address of the server itself. So again, type that 1,000 times in my lab. This is preferred. You can set any number of NTP servers as you like. We will save and continue. And then the very last thing here is optional. But it's sort of, we often get the question, and TAC will get the question too, is, what are some of the sort of, I don't know, everyday general best practices that you would recommend I turn on or turn off inside my ACI Fabric? Can you sort of give me a list so I can configure those things? That's what we're trying to do here. So I'm going to click on Review and Configure for Global Best Practices. Now, you have to read. You can't just blindly click, but it says Cisco recommends these configurations, right? But you should read the implications carefully before proceeding, and then you have to click, okay, I got it, and then you can make changes. Now, there's a number of settings here that are not the default, that over time, as we added these features or the fabric has evolved, the defaults might be better off being changed, right? And that's what each of these items are. So like, for example, subnet check. This is saying this will disable IP address learning outside of the configured subnet, right? This is probably a good thing, and it's highly recommended because, what if there's some rogue device and the wrong IP creating havoc on a subnet it doesn't belong on, a hacker misconfiguration, whatever. So you can say, yeah, I want that. So you can just tick the box. You can go through and read all the other ones, which I won't do, but there are basic things in our recommendation. Of course, all of these things, have configuration guides online that explain, what is it I'm exactly doing. But these are general best practices that we recommend you should turn on for the fabric. So once you're happy with your choices, you can say save and continue. And I said, again, that's an optional set of choices, recommended but optional. Nothing will happen if you don't configure anything there. So I've reached the end of sort of the basic housekeeping stuff. So I will go ahead and click and say proceed to summary. And let's just kind of quickly review everything I did. I see my 3 leaves and 1 spine. Everything's good. BGP, good. Out of band, fully configured. DNS, NTP, the same. At that point, there are some other things we could optionally do. like set up SNMP, set up syslog. And of course, if you need those things, you can click here and the wizard will continue and help you set those things up. I'm not going to do that today, but I wanted to let you know that they in fact exist. So I'll go ahead and say close. And that's it. So within, if I didn't talk so much, probably within 5-10 minutes, I could fully discover my fabric, set up all of the housekeeping things. Right now, at this point in time, my fabric is a fully ready to go underlay, overlay. VXLAN is fully up and operating. TEP pools have been assigned. Everything is ready to go for you to start connecting things. So just really quickly, once, just to kind of double check what we've done, is in the UI, you'll see across the top a number of sort of what I'll call high-level tabs across the top. System, tenants, fabric. So I'm going to quickly go into the fabric tab, and beneath the fabric tab, there are sort of subcategories: inventory, policies, access policies. So in the inventory, that's just like, what do I have? I can click on something like fabric membership. And again, I can see all of my leaves, all of my spines, their serial numbers, their role, the TEP IP address that got handed out from my dynamic pool. If there were any nodes pending registration, I could go here and so on and so on. If I wanted to get more information about each of those nodes, I can open up the pod 1 that they live in and continue to expand and look at things if I wanted. This is a read-only view of what I have, so an inventory. If I wanted to get a visual, what does my fabric topology look like? I can click on the topology button, and the first time you load it, it always takes a couple of extra seconds to load, but it'll give me a nice visual representation of my environment. So I'm going to click on the topology tab, and you can see there's my spine. I can hover over it and get information about it. There's my APIC. There's all my leaves. I can get information about health status, faults, things like that. But it's just a quick visual reaffirmation that my fabric is discovered and ready to go for actually connecting things. So that's what I call sort of the housekeeping and fabric discovery stuff, based on the best practices that Chris and I have sort of talked about. So now that the fabric is up and discovered and ready to go, what do I do? What's the next step? So let's connect some things to the fabric itself, right? So in my particular lab, what I would like to actually show you is I have sort of, removed the clutter, and I'm only going to focus on leaf 101 and leaf 102 here. And what I'm going to do here is my goal number 1 is connect the blade server chassis to ACI leaves with a virtual port channel, right? In my environment, I'm using a UCS Blade Series or B Series chassis from Cisco, but it doesn't have to be Cisco. It can be, any vendor, because it's a multi-vendor world, and that's perfectly okay with us. So I've got a B Series chassis here, and I'm going to actually do not 1, but 2 port channels from these little things called fabric interconnects that sort of front end my Blade Series chassis. So I need to create a VPC pair between leaf 101 and leaf 102, so a VPC domain. And then I need to configure ACI to, on these ports 117 on leaf 101 and 102 for VPC A, and then a second VPC B on Ethernet 118 on leaf 101 and 118 on leaf 102. I purposely chose symmetry there because it just makes configuration just a little bit easier. It doesn't have to be symmetrical, but it's just a tiny little best practice preference. There's too many P's. So anyways, that's what I've chosen, but just to make things easier. So that's what we'll do. And then what's running behind these fabric interconnects here is a series of blade servers. And on one of those blade servers, I've actually already installed NESXi hypervisor, right? And so what I want to do as goal number 2 is integrate APIC with the hypervisor that's running on that blade so that I can deploy networking related policy towards my virtual machines. And the reason why I like to show that is because that's a really, really slick integration between APIC and vCenter that allows us full visibility between the underlay and the overlay, what's running there, all the way down to the virtual NIC on the virtual machine. It's quite powerful, and it makes, let's say, visibility, troubleshooting, optimization really, really nice between the physical world of ACI and the virtual world of, in this case, VMware. I chose VMware because it's the most common, but we also support Microsoft's SEVMM. We support Red Hat integration. etc. So, we're sort of vendor agnostic when it comes to what you connect to the fabric. So in my example, I'm just going to integrate with vCenter and ultimately deploy some virtual machines that are on a Blade server connected through the setup that you have here, right? So let's actually go and do that. Let's make that happen. So I'm trying to escape out of this. So let's go back to ACI. So whenever I need to connect something to a front panel port in ACI, where would I go? So remember I said we had these major tabs across the top. We're still in the Fabric tab. And in this particular case, I'm going to go into Fabric Access Policies. I want to sort of point out that as you get familiar and comfortable with where to click in the UI when you first start using ACI, the Fabric tab is going to be always where you go when you're ready to connect something to the Fabric itself. And the configuration is always going to be under Fabric Access Policies. It's, personally speaking, it's where I, when I'm connecting things to the Fabric, it's like 90% of the time I'm in this view, right? So we're going to go into Fabric Access Policies. Forget about all of this sort of stuff here on the left. There's a lot of things we can click and click and click deeper. We have tried to make it easy for you to connect things to the Fabric and then move forward very quickly. So that's what I'm going to do. So in this view called Quick Start, right? There's a series of, let's say, step-by-step wizards that will allow you to very quickly connect things to your Fabric. And in my case, my VPC pair going down to my UCSB series. So if you read through these, what I want to do is I want to configure an interface, port channel, and VPC. This is the wizard that I want. So I'll go ahead and click into that wizard, and it will bring up a new UI. And the UI is going to basically prompt me for a series of variables or questions about how is this thing connected to the Fabric, and I'll take care of all the rest. So that's one of the beauty things about APIC is we tell it the outcome that we want, and APIC programs everything that needs to be programmed, where it needs to be programmed, and when it needs to be programmed. So the very first thing I would do, because this is a brand new Fabric, is I need to create a VPC domain. This is something that you would do in any network that's using VPC. So I do this down here in the lower left. So I need to, just like any VPC in any network in the world, I need to give it a number. And then I need to tell ACI which leaves will be the members of this VPC pair. So in my case, node 101 and node 102, which represents leaf 1 and leaf 2. I'll go ahead and click Save. That's easy, done, right? I mean, how fast was that? My desired outcome was make me a VPC domain. APIC says, give me a couple of variables like which nodes and what number do you want? I'll do the rest. It's done. In a legacy environment, I might have to type many more commands to get that to be in operation. But here we have ACI doing the work for us. The next thing that I want to do is actually want to create the VPC now that I've got the domain sitting there waiting for me to go. So here in the right, you see this big green plus mark. It says click plus to select switches, right? So I'll go ahead and click that, and it's going to bring up me to say which switches are we working with, or where are these things connected? Tell me which switches or which leaves. So here in the pull-down menu, I'm saying I'm working with these two guys here, 101, 102. It's going to ask me to give this grouping a name. They call it a switch profile. Any name you want, right? So one of the things that you'll have to think about is what's the naming convention that makes sense for you. And yeah, we really can't give you a best practice other than something that makes sense for you is pick what works best for you. So I'm just going to call this VPC. I need to learn how to type 101_102. Just that's my own indication as what I want to name this pair. Then if you look at the image again, it says click plus to configure the switch interface. So what we've done now is we've said, here's the switches I want to work with. Now ACI is saying which interfaces on those switches are the ones we're going to be doing. So I'll click the green plus again, and this will bring up a number of things that we will need to make a choice. So the first thing we need to do is what kind of interface type is this? Is this a single access port? Is it a port channel? Is it a VPC? We also support fiber channel with ACI or fiber channel, port channels as well. In this case, it's a standard VPC, so I need to select that. Next question is, any of the boxes in red are mandatory fields? So in this case, it's saying, well, which interfaces are participating? If you remember, on leaf 101 and 102, I picked the same interface of 117. So that's what I need to input here. So 1/17. When you do a VPC, ACI says you want to give this VPC a name. So again, when it comes time in the future to look at this or troubleshoot, the name is something that makes sense to you. So in my case, I'm just going to go ahead and call this VPC-A, right? Because this represents this VPC-A right here. So that's the name I want to call it. You pick a name that works for you. That's pretty easy so far. Down here in this sort of big middle section is we have something called an interface policy group. All this is a list of behaviors that these ports in this VPC should have. This is how these ports should act. Not all of these things are required. These are all interface options for you. In this particular case, there's a couple of things I need to do to get my VPC to work, and I will do those now. But this is basically all of the options that you can have at the port level for behavior. So one of the policies that I have is ACI supports both CDP and LLDP. In fact, you can have them both on at the same time. It's helpful to know that if they're both on at the same time, LLDP becomes sort of the preferred first protocol. And then if that's not working, CDP. So in my case, I've chosen to use LLDP in my environment. So what I want to do is I want to create a policy that says, well, I would like to make sure that CDP is actually turned off. So I'm going to make a policy that I'm naming CDP off. And again, any name is appropriate. You pick yours. And then I'm going to say admin state disabled. But what I really want to make sure is that I have an LLDP policy that actually is LLDP on. So I'm going to create one that's called LLDP on because as a human being, it'll be easy for me to identify what's actually going on here. So I'm going to create that policy. And then the last policy I want to create is down here in the lower left, port channel policy, because remember, it's a VPC. Now, there is a default object that I could use, but if I don't want that, I'm actually going to create my own. So create port channel policy. And in my environment, if we look back over here, I'm actually using LACP active between the fabric interconnect and the leaf pair, right? That's the choice that I've made. So I need to make sure I have a policy based on all of these choices, LACP active. I need to give it a name. And of course, I'll be super creative and call it LACP_active. So I'll go ahead and click submit. So those are the policies that those ports will inherit in terms of how they should behave. That's probably like the hardest part. The most typing is right there. So everything in this middle section, the way I like to think about it as a network admin is everything about the front panel ports, the switch, the interface, how it should behave. This section down here at the bottom that says attached device type, the way I like to think about it is I'm telling ACI what's at the other end of the cable, what's connected to the switch port at the other end of the cable. And we have some choices. And if we can tell ACI what we're connecting here, ACI will generally take care of the rest. So if I click on the pull down, you can see that there's a number of choices from bare metal to Hyper-V hosts, fiber channel, etc. And in my case, in this example that I'm showing you, I actually want to connect to virtual machines that happen to be running on a server behind this port channel. So I'm going to choose ESX host. So the next set of questions are all related to how is that VMware domain set up at the other end of the cable. So I need to give it a name, what we call a domain name. Nothing to do with the Windows domain, but in ACI, we have to categorize when we connect things to the fabric. Is it a virtual device or is it a physical device? Those are two examples of kinds of domains. So I need to give it a domain. In this particular case, this will be the name of the distributed virtual switch that ACI will make a call to vCenter and say, hey, I needed a DVS. Can you please configure one yourself with these network parameters that I've asked for? This is what's going to happen. So this is going to be the name of my DVS. So my domain name is called VC_DVS. Now remember that name, because when I come back to my vCenter, this is the view you're seeing now at vCenter, is I don't have a DVS yet. But once I complete this step, APIC will call vCenter and ask it to create this switch for me with these parameters, and we'll prove that that happens. So domain is done. The next thing is I need some VLANs, right? Because of effectively what I'm trying to do is to say, when I start connecting things, virtual machines, those virtual machines need to go into port groups. Port groups need VLANs to operate, right? Port groups need VLANs to operate. So ACI is saying, can you give me a range or some available VLANs to work with? And in my environment, I have a range of VLANs already decided, right? Now, I've given it a range, right? I guess, Chris, do you have a good way to describe sort of how VLANs work, dynamic VLANs versus static VLANs sort of work in an ACI fabric?
Yes, I do. So the goal here, right, is if you think about the steps you need to configure a VM so that it gains network access. In a classic environment, there's quite a bit of coordination that needs to happen between the virtualization team and the networking team. So imagine you create your virtual machine and you would like the VM to talk to your other web servers. Well, you can't just create a port group in the VMware vSwitch and pick a random VLAN, because if you do that, obviously the switch on the other side might not be aware of the VLAN that you picked. So you need to place a call to the networking team and say, hey, I would like my VM to become a member of the web tier. Which VLAN can I use on my virtual switch? And then they have to look up an Excel spreadsheet or a CMDB and tell you, oh, you can use VLAN 50. But by the way, where is the VM? Meaning on which physical port are you going to be sending traffic on VLAN 50? Well, you probably don't know that as a virtualization administrator. You go, I don't know, I just want to start a VM. Where it is, you tell me. So this is where provisioning networking for virtual machines takes a long time. In many companies, we hear people tell us it takes days or weeks, which is completely crazy, right? I mean, today, there's no reason why you want to wait so long for a VM to gain network access. So what we have done is simplify the problem. You give ACI a pool of VLANs, which we call dynamic VLANs. You will associate that pool of VLANs to a vCenter, and ACI will create a distributed virtual switch, which it will then program. And what's going to happen is when you create an endpoint group, which is where workloads are going to join that endpoint group, you simply tell APIC, hey, look, that VLAN pool, take a VLAN from it and assign it to a port group in the virtual switch that corresponds to that endpoint group, to that EPG. So all you have to do as a virtualization admin is connect the VM to the port group, and you already know that the VLAN is provisioned on the infrastructure, because ACI will discover where the VM is through LLDP and the API of VMware, and ACI will configure the VLAN on the right interfaces automatically for you. So that's what a dynamic VLAN is. It's a VLAN that is managed on your behalf by ACI and provisioned only where it is required.
Perfect. Thank you, Chris. So I've created a dynamic pool. I don't know which VLAN is going to get handed out to my port groups, but to be honest, it really doesn't matter, because like Chris said, ACI handles it and provisions everything for you. So you don't have to worry about it. That's another nice thing. We need a VLAN, but we don't really care what number it is. To continue on with creating this integration between APIC and vCenter, we need to give APIC login credentials to vCenter. Doesn't have to be super admin root level stuff. It can be something like network operator role. Basically, all we need is the ability to push configuration towards a DVS switch. So we need at least that minimum. I think there's a half-page white paper. It's super short about the minimum role that you need. In my environment, I'm using the admin account, but that's only because of laziness. You would probably create a specific account for APIC. So I have the login name, and I need to also give it the login credentials. This is for APIC to log into vCenter. So I've got that. The next bit is, well, where is the vCenter? What IP address do you have, and how do I reach it? So I'm going to give it a name. I'm going to call it VC6, because I think I'm running 6.7. We support everything back from 5.1 all the way through vSphere 7, which is the current release. What's the IP address of my vCenter? Well, I'll go ahead and put that in. DVS version, as you know, VMware DVS, because we're working with a native VMware DVS. We're not overwriting it or pushing our own. This is VMware's native DVS, right? So VMware supports any version. So I think in my case, because I'm running the version I'm running 6.6 would be appropriate. And if you make a mistake in the numbering, of course, it will tell you in red. So this is my IP address. This is the DVS version I want. Stats collection. I usually enable this, and what this does is APIC and vCenter will share information, statistics, faults, all kinds of information about the nature of this VM, where it's connected, what ports in the ACI fabric, which tenant and VRF does it belong to, so that you have a full picture. I find that very useful, so I turn it on. The last question is data center. Well, what data center are we talking about here? Well, we're talking about the VMware data center. So whenever you deploy VMware, you need to first create a top-level object that they call a data center, at least one of them. I have named mine AMS6 that you can see here. That name must match, because otherwise APIC won't know where to tell vCenter to put this DVS. So I'm going to say OK. And then at the very bottom here are some other things that look like they're related to switch level policy. And these have everything to do with the virtual switch policy. Just want to contrast that to the policy up here, which was the physical ports of the fabric interconnects. This is the virtual switch. So they each have their own, oftentimes different set of policies that are required. So in terms of port channel mode, well, in my environment, I don't use LACP down to the virtual switch. I actually use sort of the default behavior of ESX, which is what they call MAC pinning. A VM joins, pins to a certain path, another VM joins, pins to another path, and so on and so on. So I want to make sure that that matches for my environment. So I will pick the appropriate virtual switch port channel policy, right? And then the last thing is vSwitch policy is the vSwitch using CDP or LLDP. And in my environment, it's LLDP, if you remember. And that's really all I need to do. So I'll go ahead and click Save. I'll click Save again, because I'm sort of backing out of the wizard now. And then I will click Submit, right? Now, we can click and see, everything that we've just done here. These are the VLANs. Here's the port. It's a VPC. Let's quickly go back to VMware. And in a moment, if I did everything right, which I may have made a mistake, I should see a virtual switch show up here. It should have been here by now, so I probably made a mistake in the password. So I'm going to go to my virtual networking tab, where this integration actually lives, go into VMM domains, and click on my VMware. I probably have a fault here. And it looks like I do have a fault. This is always the danger when you go live, but it looks like I'll have to sort of fix these. Let's go over here and see what I will do. Well, I think I've been talking for an hour and a half. What I think is appropriate here is if we take maybe like a 5-10 minute break, we can pause the recording, and then by the time we come back, I'll have it fixed, and I'll show you what I did, so I wasn't doing any kind of cheating or anything like that. So Federica, could we pause the video and maybe go to a 10-minute break?
Yeah, Federica, pause the recording. Yeah, okay. Go ahead, Federica.
So I think it's 2:30 Central European time. So let's come back at 2:40.
10-minute break, everyone. We'll be back in 10.
Okay, thank you.
This meeting is being recorded.
Oh, unmute. Thank you for unmuting me. We're a minute early. I didn't know if I should wait for everybody to get back, but just might as well just move forward and press on, and people will see the recording if they're back a minute late. So I figured it out. It was definitely user error on my part. What I had done, let me go back to ACI, is in my VMware controller, when I was putting in the IP and the credentials were right, but thank you to the person who pointed out that they worth checking. What I had mistyped was the IP address of vCenter, and I didn't double check it before I clicked submit. If you rewind the video when you watch this, I put 10.50.120.204 when it should have been 129. So that was definitely what I call an ID 10T error, my fault. So I just wanted to go back and show you that we have our things configured. But what I really wanted to show you right before the break was, now that we have connected something to the fabric and done what we call VMM integration or hypervisor integration, what's actually happened in the background? Well, a couple of things. I have logged in to the UCS Fabric Interconnect because I'm also, quote unquote, the server admin, and I'm on the LAN tab, and I had already pre-configured this side of the VPC as a VPC, and we can see its overall status is up. That's a very good sign. But more importantly, something else happened at the vCenter level. So over here, I'm logged into my vCenter, and dynamically, I know you didn't see it happen as I didn't do it manually, but a DVS automatically showed up with the name that I chose when I configured it in APIC. So what's actually happened here? So APIC has an API, vCenter has an API. We have established two-way communication between both of those two managers. So whenever I need to affect network policy or anything to do with things connected to the virtual side of ACI coming through vCenter, APIC and vCenter can coordinate and automatically provision everything in between automatically for you. No longer, like Chris said, do you need to guess about the VLAN and which port group and which host is it on and where is it connected. APIC is aware of that and will communicate to vCenter what it needs, and vCenter will provision the native DVS for us, right? It's really, really nice cooperative operations between the network team and the VMware team or the virtualization team. So that particular DVS has shown up for me automatically. Now, it doesn't have a whole lot going on. It's just basically an orphaned DVS sitting there. At this point, we do need to ask the VMware admin, can you please attach this DVS that just came into creation to the appropriate physical ESX hosts? So fortunately, I know the VMware admin because he's me. And so I'm going to go ahead and do that step, which is the VMware admin responsibility, not the APIC. This is, of course, by design, right? So I just need to basically add a host where I've got virtual machines connected through this VPC. So I'll go ahead and do that. In my case, it's host 104, this guy right here. So I'll click that, say OK. Next thing is I need to manage the physical adapters. Now, this particular ESX host has 6 adapters. I happen to know, because it's my lab, that it's VMNIC 2 and VMNIC 3 that are the ones that I want here. So I'm basically just assigning those VMNICs to my uplinks. So this is, again, something the VMware admin would do, so go very quickly. Don't need to do anything with VM kernel, just nothing to change here, so I'll go ahead and click next. I have the option to migrate virtual machine networking, but yeah, I'm not going to do that here. I could, but nothing to migrate yet. So then I'll go ahead and click next, manage, ready to complete, and say finish. We'll see down here that now this particular DVS is connected to host 104. So that's what we need there. Let's quickly go back to ACI, or rather, let's look at the slide again. I've configured this VPC, right? And you saw me, create policies and do all of this stuff. Well, the thing I want to point out here is you only do those kinds of policy creation things in the very beginning. From this point forward, I can reuse all of these policies that I've already created. So the first time you connect something, yeah, there's a little bit of extra work, but after that point, it's all smooth sailing because I can just select and reuse. Let me show you what I mean, because I want to configure VPC-B now, which I haven't done. So I'm going to go back here and I'm going to click on my VPC pair here, which you can see is 101, 102. It already knows I'm working with the VPC pair because it's now asking me to say which interfaces. So I'll very quickly do that again. VPC, in this particular case, the VPC-B is using a different port, 1/18. I'll give it a name, VPC-B. But when it comes down to interface policy level behavior, I'll go ahead and just basically select the policies that I've already created. I can reuse these things thousands of times to infinity. Same thing is true for the port channel. There's my LACP active. And then when I scroll down here, what's attached to the other side? Well, this is basically an alternative VPC to reach the same ESX host that I did in the VPC before, if that makes sense. So rather than create a new one, I'll just go ahead and choose one that already exists because I did that work already, right? There's no need to repeat. And you can see when I select choose one, the VMM domain that I had created was called VC_DVS. And again, I can just select my existing port channel policies, LLDP, to match, say save, submit. Second VPC is done. So again, the first one was a little bit longer because I had to create some of the policies first. Second, third, fourth, 1000th VPC on this group is I can just reuse those policies forever. Now, coming back here, it's going to take a minute for that port channel to come up, but right now you can see link up, but the channel is still forming, so we'll let that stew, right? So at this particular point, I can say with confidence that I have achieved both of my goals, connecting a Blade server chassis with VPC and then integrating to the hypervisor, because on one of the Blade servers running behind there, I have VMware ESXi installed with some VMs. So now what do we do next? Now that we have something physically connected to the front panel ports, now you're probably thinking, that's nice, Joe, but get those VMs to talk now, right? I want to see them talking to each other. So this turns a page. So the new chapter is, there are some things we need to do, not at the fabric level, but at what we call the tenant level. There's some objects and some policy that we need to create so we can put these VMs in their home where they belong. So there's some basic building blocks that you need to be familiar with, and I'll talk about them first and then show them second. So the basic tenant hierarchy is, well, obviously we need a tenant. We need to create a tenant in ACI. And in this case, it's probably the most simplest object in the world because it just has a name, right? So we need to create a name. And the way I view a tenant is it's really just like a container to keep things organized. It's like a briefcase that you put all your papers in, right? So we need at least a place to put these things. So we'll create a tenant name. Inside the tenant, we need IP routing space, right? We support IPv4 or IPv6 if you want. You can have multiple VRFs in a tenant. In my case, I'm only going to create one, but we need at least one, but you can have more in the same tenant if you like, right? That's possible. So now that we have a full IPv4, in this case, routing space at our disposal, we want to basically, carve that up into maybe some smaller segments, right? So we need a concept that we call a bridge domain. And different people describe this differently, but I'll tell you the way I imagine it in my own head. It's sort of a new name for something that you probably already understand. So a bridge domain can work at layer 2 or it can work at layer 3, right? It depends on what you're going for. And the example that I like to give to sort of explain my way of conceptualizing this is, if you think about a traditional NXOS switch, legacy pre-ACI, if I had a Nexus 7K and I wanted to configure Ethernet port 1/10, and if I were to type the commands, config T, interface ETH1/10, switch port access VLAN 20, how is that switch port behaving? Well, it's a switch port. It's layer 2 tagging VLAN 20, right? That's how I've configured it. Now, if I stop there and I erase that config that I just made, and I type these commands instead, so interface Ethernet 1/10, no switch port, IP address 10.20.1.1/24, no shut. Very exact same port, but now how is it configured? Well, it's configured as a routed port. It's probably my default gateway for anything in that particular subnet. So it all comes down to, am I wanting to do something at layer 2, or am I wanting to do something at layer 3, in which case it would be my default gateway. These are the jobs of the bridge domain, right? So we can set layer 2 flooding, we can set routing, default gateway, things here depending on what we're after. So we usually, in this case, I'm going to create a routed bridge domain, and there's usually one BD per subnet. Of course, you can have multiple subnets under a bridge domain, and an ACI fabric is going to potentially have many, many bridge domains, right? I'm only going to create one, and I'm going to attach a subnet to it in the simplest example. So once we have our bridge domain, so we have a segment or a subnet that we can sort of work with now at a lower level, we need to create something called an endpoint group. And an endpoint group, it's an ACI term, but it's actually where you put your endpoint. So in an ACI fabric, or the way ACI views the world, is everything's an endpoint. And that endpoint can be physical, that endpoint can be virtual, but they're all endpoints and we treat them all identically the same. But we need a place to put them for us to apply common policy. So like, for example, if I have a bunch of web servers, physical, virtual, or a mix, I might decide, well, they've all got the same policy. I can treat them all the same. So let me put them into a group and apply the policy to the group and be done with it. So this is what we call an endpoint group. And so in an ACI fabric, you are going to, number one, attach or associate an endpoint group to a bridge domain. And then what you're going to do is you're going to then put endpoints inside this endpoint group. So a typical ACI fabric will have many, many EPGs. It's just how we organize endpoints and apply common policy to them, right? That's an endpoint group. We need those. It's one of those fundamental blocks of ACI. Inside that endpoint group, we have to tell ACI where its endpoints are. And in order to do that, we map this thing that we call a domain. And if you remember half an hour ago, I mentioned that in the ACI context, a domain is just simply a way for us to identify endpoint types. So this is a domain of virtual machines. This other domain is a domain of bare metal machines or bare metal devices, right? It's just a way for us to organize them. And what we could do is then map that domain to the appropriate endpoint group and thereby establish endpoint membership in that group. We need to do that mapping. And this is very conceptual on the slide, but once I show you in an ACI fabric, it should hopefully make better sense. So let's actually go and build that. So let's quickly check. Yeah, our second VPC is up, so everything's looking good. So I'm happy with that. So back into APIC. Remember, the major tabs across the top are good sort of starting points that route you down into specific things. Remember I said anything front panel ports, fabric access policies. Well, at the tenant level, obviously it would make sense that the tenants tab would be where I would click. We give you some tenants out of the box. I really won't go into these other than to say that, you probably are going to be making your own tenants here. So I'll just leave it at that. So I'm going to say add a tenant. I'm going to give my tenant a name. Remember I said this is the easiest object in the whole system. I'm going to call it Acme. And there's another optional choice that I have is attaching a VRF. So down here at the bottom, it says, VRF name. I'm going to give it a name, any name I want. I'll call it V1 because I like short and sweet. You can give it any name you want as well. So I'll go ahead and click submit. It's going to create the tenant and that VRF and take me to the view of how I configure the tenant. So here's tenant Acme, here's VRF V1, already done, right? That was pretty easy. That's like half of the conceptual drawing is done, right? So what's the next level down on the thing? Well, I need to create a bridge domain. So let's go ahead and do that. So here under tenant Acme, under the networking tab, there's bridge domains, right? I can right click, right? And say create bridge domain, right? So I'll do that. And it will bring up the parameters for configuring a bridge domain. So I'll give this a name. I'll call it BD-A. Again, any name you want, but just remember, once you commit the name here, it's fixed. You cannot change it. What would you do if you needed to change its name? Well, you do things. You can give it an alias with the new name, or you can delete the object and make a new one and switch over to it. So BD-A is my object for bridge domain. Remember I said a bridge domain needs an association. Which routing space are we working with? In this case, he or she belongs to VRF v1, and that's that, right? So then I'll say next. It'll take me to the part about how do you want this bridge domain to behave? Layer 2, layer 3. In this case, I want it to be layer 3 because I want it to be the default gateway for a certain network. And so the default is unicast routing enabled, which means, yeah, act as a layer 3 concept. In the middle section here, subnets, I'm going to go ahead and click the plus button, and I'm going to add at least one subnet. So 192.168.1.1/24, right? There's some choices I can make about this subnet, but in this case, I'm going to say make this IP address as primary. Why did I do that? Well, because I just wanted to show you that it is possible, if you desire, to optionally add any number of secondary subnets to the same bridge domain. This works exactly like the secondary keyword. So by not ticking the box as primary, that designates this as a secondary. So I can say, okay, so you can see 1.1 is the primary, 1.2 or 2.1 is the secondary, and I can continue to add more networks if I want to. Just wanted to show you that that was possible. I don't normally do it, but if you need to, it's there, right? Then I'll go ahead and click next. Advanced troubleshooting, I'm not going to do anything here, but there's some things you can do around monitoring and first hop security, which is, let's say, a more advanced topic. So I'll go ahead and click finish. So there's my bridge domain, right? In fact, here is my BDA, and here's all the information about that particular bridge domain. So we'll go ahead and open that. What is the next thing that I need to do? Whoops, not there. The next thing I need to do is create an endpoint group and map it to a domain. So what am I going to do there? Well, the first thing, and I didn't do it on the drawing because I just think it kind of clutters the view, is we have this notion of an application profile. An application profile, it's just an organizational tool. It's a folder that I group EPGs into. And to get started, you need at least one. So I need to create at least one to create EPG. So I'm going to right click and create an application profile. I'll call it AN1, again, short and sweet. I could create EPGs here, but I'm not, because I'm going to show you that there's a couple of ways we can actually do that. So I'll go ahead and click submit. There's my simple application network profile, right? You need one. Again, you would have as many as you find appropriate, because again, it's like folders to organize things, right? You might have an application profile for all of your production environment, a different one for your test and QA environment, or you might want to go deeper and say, I have an application profile for all of my web servers, a different one for app servers, a different one for backup servers. You know, as your heart desires, you can organize, but you need at least one to get started. So here I've got my application networking profile. Now there's a couple of things we can do. So under application EPGs, I can right click and create an EPG. So that's one way to do it. So when I right click, the screen comes up. I'm going to create an EPG called Silver. That's just the name I'm giving it. I'm going to attach that EPG to my bridge domain A that I created in the step before. And then I'm going to say finish, right? That wasn't so bad, right? So I want to show you, I want to create a second EPG as well, and I'll show you a different way to do that. So if I click on the application profile name of AN1, and I go to the topology tab, we added this thing that we call, what do we call it? Like the canvas, right? The canvas sort of allows you to click, drop things onto the canvas and associate things to them and get things to work. So you can see I've got my EPG Silver there. I want to create another EPG alongside of it. So I'm going to click on the EPG object from the canvas palette at the top and just basically drop it anywhere on the canvas. And you can see a window pops up. I'm going to call this EPG Gold, and I'm going to map it to the same bridge domain, right? So you can see here, I'll go ahead and click submit, so which kind of commits it. I've got my two EPGs, Silver and Gold. If I hover over them, you can see which bridge domain they're attached to, which VRF they're in. all pretty simple. So I've got these two EPGs. Now the next step is I need to do the mapping. I need to say, how does an EP or how does an endpoint find its EPG membership? Like, how do I affect that or make that happen? And this mapping is the way we go ahead and do it. So again, there's a couple of different ways. I'll do them two different ways. So the first one, I'm on the canvas, so I'll do it now. There is a VMware object up here in the palette. So I'm going to click it, drag it. I'm going to drag it on top of silver and say, on top of silver, I want to make an association. I guess that didn't take, I got to drop it. Let me try gold. Why isn't it working? That's okay, because, well, when the canvas isn't working, we can do it another way. So let's go under silver. And the first thing here says domains, VMs, and bare metals. This is how we can make the mapping as well. So I'm going to right click and say add a VMM domain association. From the pull down, I could have any number of DVSs at my disposal. I only have one, so that's an easy choice. I'll pick that. I can make some choices about how APIC programs that, on demand or immediate, like do it now or only do it when you need it, etc. And then I can make some choices about how the port group is configured in vCenter. So reject, 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 which I think is the default. But of course, I can change those, right? So I can say that's Mac changes accept. And I will say submit. If I go back to my canvas, you can see here that EPG Silver now has an association to this VM domain in this vCenter, right? Let's try that again with gold. So I'm going to click and drag onto gold. Yeah, it worked this time. And I'll go and select my VMM domain association this way, and I'll click this. Now, the thing about this, using the canvas, that I don't prefer is that it didn't give me all of the choices about Mac changes and promiscuous and immediate. It was just kind of like down and dirty. I want to get this mapped as fast as possible. So it's a workable way, but if you want to go deeper, you see you'd probably have to go back into it and make your changes. So you can see I've got my mapping between gold and silver. Now let's really quickly look and see what happened over in the VMware vCenter world. Well, here's my DVS that we had created, a little bit ago. But notice here, there's a couple of port groups. And if you look at these port groups, there's a certain naming format. So Acme, which is my tenant name, followed by a pipe, followed by AN1, which is my application profile name, followed by a pipe, followed by the word gold or silver, which are my EPG names. And I kind of like that. I mean, you can change those delimiters, but that's the default. I kind of like that because imagine now you're the network person and you're troubleshooting a problem and it happens to be in the virtual world. So the VMware admin is on the phone with you and together you're trying to figure out, okay, where's the problem? What's going on? How do we fix it? Having knowledge, intimate knowledge about which port group corresponds to which EPG allows both parties to immediately hone in on that part of the network and start the troubleshooting as quickly as possible. So again, a nice cooperative interworking between the teams here based on this integration. If I click on EPG Silver, what VLAN did it get? Well, it was going to be somewhere between 900 and 940. This one got 900 and gold got 928. I don't know how the numbers get picked, but it picks them from the range. So I've got port groups that are attached to a network that have the proper VLANs. VLANs are fully provisioned automatically in ACI. At this point, I can connect my VMs to these port groups and start sending traffic. So let's actually do that. So I have a whole bunch of VMs in this environment. So in this particular case, I'm going to work with two VMs, Win8-Silver and Win8-Gold, right? So the names kind of correspond to the EPGs. So this is something that the VMware admin would have to do. This is not something the ACI admin should do, but basically, assign VMs to their proper port group. So I'll put him in silver and we will say, okay. And I'll put gold in gold really quickly. And now I have joined them to their port group. So let's go back to Win8 Silver. And I'm going to open up the remote console. of that virtual machine. In fact, I'm going to open up both of the virtual consoles so we can actually have an understanding about what's going on. Give them a very brief moment to load. And it looks like they have loaded. Okay, so let's, and I used clear, yeah. Okay, so what's the IP address of Win8 Silver? He happens to be 192.168.1.11. Let's just make sure he can ping his default gateway, which is, in this case, my bridge domain, A. And if you click out, he's getting a ping. So he is connected to the fabric. VLANs, everything is all sorted for me already by the dynamic programmability of ACI. Let's look at Win8 Gold, and let's have a look at this IP address. Happens to be same network, but at 1.10. Let's just double check that Gold can also ping the default gateway. Yes, everything is good. So I've got endpoints connected. I've got them in their EPGs, everything mapped, VLANs provisioned, VPCs are working. Now the test becomes, can, let's say, Win8 Gold ping Win8 Silver, right? You would think that's going to be an easy one, right? They're on the very same network attached to the very same bridge domain. So let's actually go ahead and start that ping. And it's not working. It's failing. What is going on here? I thought I got everything right. Has Joe made yet another mistake? This one I can say with confidence is I made it on purpose because I wanted to use it to make a point. So let's go back to the conceptual whiteboard here, and let's quickly look at how ACI is configured from a security profile or security posture. So out of the box, by design, we have chosen what we call a zero trust model. So this means that every port in an ACI fabric is a stateless firewall. In fact, the whole fabric is a stateless firewall out of the box. You don't have to do anything. This is the native state of ACI. And it's not only is it a better security posture, this is exactly how the cloud providers do it, right? This is another way of saying nobody can talk until I actually come along and put a policy in place that allows you to talk. This is a little bit different. In fact, it's a lot different from what we've been used to the past 20, 25 years. Is it used to be, if I got link up and I have an address, boy, I can talk to anybody I want until an admin comes along and drops in an ACL or a firewall or something that tells me I can't talk. By default, I can talk. ACI takes the opposite approach. In today's world of hackers and intrusions and all of this kind of stuff, this is decidedly a stronger security posture, and it's something that we very strongly believe in ourselves. So it's also an operational change for you as the ACI Fabric admins. So we have a concept of something that we call contracts. And contracts is just a fancy word of saying policy to allow things to talk. You could call them access control lists because effectively they kind of work the exact same way. So if we think about this, if EPGs are groupings of endpoints with similar policy, we can use contracts to then define or tell ACI how these EPGs can talk to each other and what they can talk about. Because out of the box with a zero trust model, EPG 1 cannot talk to EPG 2. That is default behavior. So what about anything inside EPG 1? Well, everybody inside EPG 1 has a common policy, so they can talk by default. But they can't talk to any other EPGs unless I go ahead and say it's okay to talk. And that's what we use this notion of contract for. And so a contract is an agreement between two parties. And in this case, we can use contracts for a number of policies that we may choose to bring into life in ACI. Normally, at its very basic, a contract is used for security policy, right? Who can talk and what can they talk about? And that's what I'm going to show you. But a contract is actually quite versatile as well because it allows us also to agree between two parties about other policies like quality of service, service insertion, like this traffic should go to a firewall. We can use other advanced features like what we call policy-based redirect to say, we can create a policy that says any unencrypted traffic should go to the firewall, any encrypted traffic should bypass the firewall. It's a forwarding policy. We can also do things like microsegmentation, and when you start getting into more sophisticated things, even do stuff like SD-WAN policy through this notion of a contract. So if you look at the object on the right, we have two endpoint groups. So that's basically our silver and our gold. And right now they cannot talk. Pings are failing because we don't have a contract that says we can talk. So I'm going to create a contract, and a contract is devised of what we call filters. Filters are like access control entries, lines that say this port, this protocol, this range, etc. Right? Notice we don't use, well, you will notice in just a moment, we don't use IP addresses, right, or subnets. This is actually a little different, but also very liberating, because in the ACI world, just like we don't really care about what VLAN you have, as long as you have a VLAN, we don't care. We handle everything for you. The same thing is true when it comes to sort of segmenting based on only IP subnet, which is like the old legacy way of doing it. Here, IP address and subnet don't really matter. I mean, you need to have an address. We don't break standard networking laws of the universe, but we don't necessarily need to use IP address as the only mechanism to separate things, because IP address is arbitrary. What does 192.168.100.15, what is that? I don't know. Could be a web server, could be whatever. So here, when I say something crazy, like IP address doesn't matter in ICI, what I'm really saying is what matters? What is the thing that matters? And in the ACI world, it all comes down to which endpoint group you belong to that matters. Based on your endpoint group, policy is applied and you can talk or not talk. We don't care about your IP address. We don't care about your bridge domain. All of that stuff is like very flexible in an ACI world, and it's actually quite liberating. So with that in mind, I'm going to very quickly configure a contract with some filters so that EPG Silver can talk to EPG Gold. So let's very, very quickly get that done. So back to ACI. What I'm going to do is, you can see here in my nice canvas, I'll zoom in a little bit, is I've got EPG Gold and Silver, and there is no visual relationship between these guys, right? So I want to make a contract between them. So up in the canvas, there's a contract object. I'll go ahead and drop it on Gold, and then, sorry, I unclicked too fast. I'll start with Gold and then swing it over to Silver to make that connection between them. Now, in this concept of a contract, we have what's called a consumer and a provider. It's just different relationships. So in this case, I have chosen Gold to provide ICMP pings, or I'm about to provide that, to the person who wants to actually do the ping, which is the consumer, EPG Silver. I can, of course, reverse those, whatever. But just note that in this notion of contract, without getting too complicated into the weeds, there's always a consumer and a provider, and they meet in the middle through the contract, and then communication happens. So here, underneath the contract, I can select an existing contract, or I can create a new one. So I'm going to create a new one just to show you how easy it is. So I'm going to give it a name, just like anything else in the ACI world. So allow some traffic. There is a default choice of no filter, which basically says allow all, right? I don't want that. I mean, you might want that, but I don't want that in this example, which unticking the box brings up a filter entry, right? So I'm going to create some filters here that will allow my EPGs to talk. So the first one, I'm going to give it a name, any name. I'm calling it ICMP because, I'm not creative. Ether type, in this case, it's an IP packet, and the IP protocol is ICMP, and I'm going to say update. That creates that filter. But, I want more than just ping, right? I mean, that's boring, right? So, I think I want access to some web servers, right? Maybe between these guys. So I'm going to call it webs. Again, any name is suitable. It's an IP packet. We know that HTTP traffic is TCP, so we will call that out as the IP protocol. Over here on the right, source port, destination port. Well, we can never know what the source port will be because it's ephemeral and will always change. But we do know that the web server is listening on port 80. So from and to, the range is a single port. We'll say update. And well, I don't just want TC or web traffic. I think I want NTP as well. And NTP is an IP packet, but is UDP, right? Because I can mix and match anything that I want in the filter list. And we know that UDP 123 is my NTP server. And well, because I'm a sophisticated kind of guy, I think, there's a special app that my company has that uses a range of ports, right? It uses a range of, let's call it TCP ports in this example. So IP, TCP, the range, let's say from 440 to 450. It's a range. But Maurizio's on the call. He's not going to like that. 448 because it breaks on bit boundaries, right? You could do 450. I'm only making a joke. But so basically any range that I want, and I'll say update. Actually, he would have said 447, Joe. Anyways, so 440 to 448 is in a range. Again, whatever you need to come up with in this list, you can, right? So, and this is just one contract. You can have more than one contract. You can do a lot of different things to your heart's content. I'm showing you the simplest example. So we'll say okay, right? And then I will say submit. And you will see in a moment the canvas will display that we have two EPGs now with a relationship between them. And this relationship is a contract called allow some traffic. Hovering over it gives me the filter entries and any other policy that I might have attached here, right? So now, if I go back to my two VMs, what I said, silver should ping gold, right? That's what I said. It'll work in both directions, but if I try to ping 1.10, it now will work. In fact, if I do the ping this way, you can see it is in fact working, right? So the contract was what we needed to allow the communication to happen between EPGs. Now, I could probably go on for hours and hours just on EPGs and contracts and possibilities, but I think you got the basic idea here of what is an endpoint group, and how do we affect policy to allow endpoint groups to talk with the full understanding that ACI is a stateless firewall, zero trust model out of the box, right? We need to be aware and specific of who's talking and what they're talking about in order to remain secure. Now, from a best practices point of view, I often get asked the question, well, does this mean I can remove all my firewalls and just use contracts? And I would say possible, but not desired, because this is just, if you talk to any security person, they'll say defense in depth is a very proven, strong security approach. And we agree. So contracts is really just one layer in a defense in depth strategy that might include firewalls, might include IPSs, or any other kind of security paradigm that you want to bring into action. Contracts is just one part of that. It's not a replacement for firewalls. I mean, although you could do that, it just wouldn't be as strong as having defense in depth. That's sort of my soapbox on the security aspect. So now we've got our two EPGs talking, and I've kind of come towards the end, the last sort of stage that I'm working on is a couple of things. Well, Joe, you did a fantastic job about virtual machines. What about bare metal? So what I'm going to do here is, if you remember back in my lab, well, I've got my virtual machines down here talking, silver, gold, everything's great. But what about if I wanted to connect a bare metal server over here? So I've got a Windows 2016 server over here. I called it Hyper-V because I use it for that, but it's basically representing a bare metal server. So how do I connect that into my environment? Well, you should know the answer by now. Anytime I want to connect anything to a front panel port, Fabric tab, access policies, go into the wizard, configure an interface, port channel, or VPC. Now, if you look at this guy, he's connected to Leaf 103, not on a VPC, on a standard port channel. Yeah, so it's a little bit different. So what we need to do here is bring 103 into the mix. So he's connected to a new switch we haven't used before. And I'm going to give that guy a name, just call him N103. Just like before, click plus to configure the interfaces. In this example, 45 through 46 is my port channel. So those are two different ports. Well, that's no problem. I just do a range, 1/45 through 46. And I'm going to give this port channel a name. I'll call it, let's say, Windows channel, something that makes sense for me. Again, I can reuse existing policy, so I'll make my choices. I'm using LLDP here, and in fact, I am using, I'm sorry, I need to say it's a port channel first. I am also using LACP active in this particular Windows host as well. Now, down to the bottom, well, what's at the other end of the cable? Well, it's not an ESX host here, it's a bare metal server. So from the pull down, I'm going to indicate to ACI what's at the other end of the cable. And I can choose an existing domain or create one. Remember, I said in ACI world, there's generally two types of domains. You're either a physical domain, i.e. bare metal, or you're a virtual machine, which is a virtual domain. In this case, I've never connected direct bare metal to the fabric before. So I'm gonna create a new domain called bare metal so I can kind of differentiate them. And I'm going to create a VLAN range here for bare metal hosts. And I'll go ahead and click save and submit. And that bare metal device is now connected to the fabric. Let's actually, where is my remote desktop? Yeah, it always wants me to update. The thing here is, this is my LACP. As I was doing my testing, one of the cables or something got disconnected, but the other one is up. So the port channel is up with one member. So don't get distracted by that. I think the cable came loose, but the server is there. And if I look at, sorry, it's really, really small. Yeah, basically the IP address of this guy is 192.168.1.99. Now, I've connected the bare metal to the fabric, but remember, now I need to do something at the tenant level to tell the system what EPG this bare metal server now belongs to. So I'll go ahead and go back to my tenant, tenant Acme. I'll go into my application profiles, and let's say, which EPG do I want? Let's do EPG Gold because it's top of the list. Domains, VMs, and bare metal. The first thing I need to do is add physical domain to this EPG, right? It's different from VMM domain, as it should be. So select my bare metal domain that I just built, submit. That's one step. I've told ACI that this domain belongs to this EPG. I need to do one more thing. I need to actually tell this EPG how this domain is connected to the fabric. Just basically making the mapping of how it's connected. And we do that through what's called a static port. So I'm going to right click and choose to deploy. And all that is saying, okay, where is this connected? Remember, it was a port channel. So I'll select port channel. There's the channel I just created from the pull down list. And it's asking for a VLAN, right? Because I have here mode is trunk. I could choose access, which is 802.1p, which also requires a VLAN, but it's not trunking. It's just a tag in the header. Or I could do untagged, right? Your choice, right? All of those are possible. In my lab, I'm using 802.1p, so that means I need a VLAN. Good thing I have a VLAN in the pool. So 99 from my pool. I'm going to call that out statically, and I'll say submit. So now I've actually connected this bare metal host over a port channel, and I've given him EPG or her EPG membership into EPG Gold. Let's actually go back to the bare metal hosts. I hope this is sharing, and let's actually see. Well, actually, we don't have to do it here. I think we can do it from one of my EPG Gold. Ping 192.168.1.99, right? Is it going to work? And probably the first packet will miss because of an ARP. And the next ones, yeah, they're in fact working, right? Do you think EPG Silver or this endpoint Win8 Silver will be able to ping 199? What is your thought? Well, you're probably screaming at a muted microphone. Yes, it's going to work. And why is it going to work? Well, because Silver has a contract with Gold and they're allowed to communicate over ping. So any EPG, or any endpoint, whether it's virtual or physical, is going to work. Now, a couple of interesting things to kind of finish up on this and get on to the very last topic is, how do I know what endpoints are in an EPG, and how do I know where they're connected, what IP address, blah, blah, blah? Well, if you click on the EPG name, so I'm going to click on Gold, and in the screen to the right, there's a tab called Operational. And when you click on Operational, this is going to give you all the information about that EPG. Let me see if I can actually make it a little bit larger. It's easier to see. So I can see endpoint name, Win8 Gold, MAC address, IP, how I learned it. I learned it through data plane and through my VMM integration, because this is a virtual machine, remember. Which ESX host is it on? Well, it's on host 104. Which vCenter is reporting it? Well, VC6, the one I set up. What path is it using to cross the fabric? Well, it looks like we've got a VPCA here. And which VLAN is it using? Well, VLAN 928. Interesting, right? So now if you go up here at the top, this endpoint, MAC address and IP address, this is the bare metal server. It doesn't have a host name that's being reported. Data plane learned. Which path? Well, in pod 1, node 103, using the port channel called Windows channel that I named on VLAN 99, a totally different VLAN. So in this construct of an EPG, we're completely liberated from VLANs and IP subnets as a way to separate and apply policy. Those are arbitrary values that really don't allow us to do a whole lot. Now we have the concept of EPGs. EPGs allow us to group different things on different VLANs, on different ports and switches, and yet still apply common policy to them. And it doesn't matter if it's a virtual machine. It doesn't matter if it's a bare metal. And to me, maybe I'm sounding a little bit, marketing, but I really, really like the fact that we're endpoint agnostic. We don't care whose vendor is on the virtual machine, Windows, VMware, Red Hat. We don't care which bare metal server you attach or which firewall from which vendor. We treat them all the same, and we can organize and apply policy through the EPG. And it's really, really flexible and very, very possible to do whatever you need. It's not just sort of a Cisco world, right? We're very friendly with what you connect to the fabric. So with that being said, there is something that I realize when I'm talking about visibility that I kind of overlook. So I'll take a minute. Is remember just after the break, we finished our virtual machine integration between APIC and vCenter. One of the side benefits of that relationship is this notion of visibility, right? So I'm going to go into the virtual networking tab and say, well, I want to know information about my vCenter. So I'm going to click on there, and this is all being reported by vCenter, IP address, DVS version. I can click on operational, and I can see, this is the exact build of my vCenter. This is the revision. Here's the serial number. Here's all of the hypervisors, all of the ESX hosts in my lab that are connected. Are they powered off? Are they powered on? How many virtual machines are there? You get the idea. I'm starting to be able to correlate information between the physical networking world and the virtual networking world, but in one combined view. I find that extremely powerful for the teams that need to work together to make all this stuff work and troubleshoot it when it breaks. Going down even further, I can say, well, I want to look at ESX host 104 because that's the one we've been working with. I can see it's got, 6 physical NICs, a VMK management NIC, and some VMs there. I can click on other information, like of those 6 physical uplinks, are they up? Are they down? What's the MAC address? Are there any faults that maybe would point to a problem? What speed? Et cetera, et cetera. The same thing is true for virtual machines. You can see I have a lot of machines, some powered on, some powered off. But let's say I want to go all the way down into the virtual machine itself. So I have a list of all the VMs in APIC. Let's click on Win8 Silver because that's what we've been working with. It's got one virtual network adapter that was reported by vCenter. It could have more than one, and it would show up here. What's its IP, its MAC, its state is up, which EPG it belongs to. We can even pull things like custom attributes or vCenter tags to go even more dynamic and sophisticated with how we group things and tag things and apply policy to that tag, whatever. So you can see I created one that I named infection, and its value is false because I was doing a security demo. But the point is, by nature of this VMM integration between APIC and vCenter, we gain a tremendous amount of cooperative visibility that is invaluable to the teams that need to cooperate to run the business. Okay, so that is EPGs, contracts, domains, all that kind of stuff. So now I what about getting outside of the fabric? So far, we've been in our nice little bubble of ACI. Now I have a requirement. My new goal is connect these guys to the internet, right? Connect them to the outside world. So in my environment, I'll very quickly show you, and still leave some time for Chris, I hope, is on Leaf 103, port 119, I've connected a physical firewall. It could be virtual as well, but in my lab, I have a physical firewall. It happens to be an ASA. It could be any vendor's firewall. It doesn't matter. It's just another kind of bare metal endpoint, right? So we're going to connect those two together and run OSPF over that link. And on the outside interface of the firewall leads to basically the Cisco corporate network and the internet, right? So I can actually get to the internet and I'll prove it. So we have this notion that we call a layer 3 out, right? It's called a layer 3 out, and this is what I need to configure really quick. So let's go and do that. So back in my tenant Acme, where we've been doing all of our work at the tenant level, under the networking tab, where it would make sense, there's a folder called layer 3 out, and there's nothing there, right? So I need to make one. So I'm going to quickly create a layer 3 out by right-clicking and selecting it. It brings up a wizard, right? I just need to, again, tell ACI the outcome that I want, and it will program everything that needs to be programmed for me. So I need to give it a name. So I'll call this ASA INET. Again, any name that makes sense. What VRF? Well, VRF v1. That's the only one we have. Layer 3 domain. This is another kind of domain just for layer 3 outs. I don't have any. I don't have one. So that's okay. I can create one on the fly. So I'll call this ASA INET domain. Again, whatever name that you want. There's something called an AEP that I haven't talked about, but basically just ties this domain in with all of the other objects. So I believe I'll pick that one. That should work. I could choose a VLAN pool. I'm not going to, and I'll explain why in just a moment, because I have some choices here, and one of those choices doesn't require a VLAN, so I'm not going to use one. So we've got that set. The next choice is, what's your routing protocol? In my case, I've chosen OSPF, so it will then show me OSPF relevant things. In my environment, it's area 0. It's a regular area, standard OSPF choices, nothing mystical there. I'm going to go ahead and click next. The next thing is, it says, okay, listen, you need to tell me where is this firewall connected, on which leaf, and on which port, and how is it connected? Is it a port channel? Is it an access port? Is it a SVI? Is it a sub interface that's routed? Is it a directly connected routed interface? What is it? So in my environment, it is a layer 3 interface, directly connected layer 3, no VLANs, just point-to-point, IP to IP. It is over a single access port. Obviously, if I was smart, I would have done a port channel for redundancy, but it's my lab, so I can get away with it. It's a single port. The next question is, which leaf are we talking about here? Well, it's leaf 103. We need a router ID. This is like a loopback address for standard routing router ID. And I think in my environment, I said 51.111, right? That's what I've chosen as my router ID. It will automatically create that as a loopback. No big deal there. Now it's asking me which port on leaf 3. It looks like we're 1/19 loopback. So I'll go ahead and select 1/19 from the list. And what's the IP address? What is my side of the OSPF neighbor adjacency? And I think I wrote that down. It's 5.5.1.2/24. Probably a larger mask than I needed, but that's what I chose. So there we go. We'll go ahead and click next. The next thing is there any OSPF specific behavior that I want to bring into effect here? So is there a policy here? So there's a default policy out of the box. It doesn't look like I can create one here, but I'll show you where you can create one. So I'll just select default policy. But you're probably wondering, well, what's actually in the default policy? When you see that little blue double square icon thing, if you click it, it actually shows you what's in the policy. So that's good because I actually am a point-to-point network. I always pick MTU ignore because OSPF checks MTU, and if they don't match, it will come up, and I'm always off by 20 bytes, and so I just do MTU ignore, and I'll choose to advertise subnet. You have some choices here. These are my choices. You will pick the ones appropriate to your environment, but that's my environment. So I'll submit that policy, and we're good. And I'll go ahead and click next. finally, I arrive at this notion of what's called the external EPG. What is the external EPG? Well, remember earlier I told you that ACI sees the world as a series of endpoints. And we group those endpoints into EPGs, as we did with silver and gold, right? But what about things that live outside of the fabric that ACI doesn't control? It's not connected to ACI like directly to a port. What about that? Well, we have this concept of the external EPG, and all that is everything in the outside world. We can tell ACI, well, that is an EPG because that's what you understand, but it's an external special EPG that represents things outside of your control, direct control. But we need to define what the boundaries of the external EPG are for you to allow communication over OSPF, back in this example. So I'm going to create an external EPG called Internet Nets, right? It's asking me for a provided and consumed contract. Let's just leave that out for now. Just let's create a simple thing. If you leave this box enabled, which is the default, it says default EPG for all external networks, right? That's basically 000/0, right? You don't have to do that. You can get specific. And if you untick the box, it brings up a subnets category. And so if I click the plus button, I can add more specific networks if I wanted, any number of networks, any kind of mask, whatever I want to define. In this case, in this example, I am actually going to the internet, so I am going to use an all zeros route, but I wanted to at least point out that you can be more granular and specific and have multiple subnet entries in this list. It doesn't have to be just one, okay? I know what, yeah, so, and then we're going to give it a name. So we'll just call it all nets, whatever. And we'll say, okay. So now I've defined the scope of the external EPG in ACI terms. It's basically the whole world outside of ACI, 0/0. So I'll go ahead and click finish. Now, while I'm doing that, let's actually log in. The firewall itself has been pre-configured by the firewall admin, but let's go ahead and log in to that firewall. I happen to know the firewall admin because he's me. So if I do show OSPF neighbor, you can see it's currently down. I noticed that the ASA takes a few seconds to figure it out. So let's see if we can actually ping. We can ping the other side. So it's just a matter of time before this OSPF comes up. So we'll give it a moment here. It will come up, I swear. I tested it 1,000 times. So it's probably like in this timer phase, but we'll give it. It should go into a NIT by now because you see I can ping the other side. So I know that the communications is there.
Is your MTU okay?
Yeah, I did MTU ignore. All right, I did MTU ignore.
On the ACI side as well?
Yeah. Oh, come on. Of course, doing this thing live. So what would I do here to sort of check what's going on? So if I go, oh, interesting. Did I not click submit? Interesting.
I guess you did not.
I've never seen that. Let's do it real quick again. Let's not talk. This is probably something germane to my lab. I mean, I've never seen that before. Regular area 0. But what's weird is, no, I'm not going to do this. It's going to.
Well,
let me click off the tenants and let me click back in because it's there because the.
No, it's not. I'm logged in as well. It's not there.
Interesting. Okay. Well, we'll make it again. It could be, nerves because I have a live audience. So I'm just going to do what I just did really quick.
You can have a browser issue as well sometimes.
Yeah. So it is leaf 3, router ID. Just make sure we're consistent here. And it is 1/19. And the IP address, again, should be that. Next. Default. Next.
Use a routed interface or an SVI, or because you didn't specify anything.
Yeah, interface layer.
Okay.
Yeah. Okay, so next, we'll call this something different. We'll just do the default because you already saw how that's created, so I'll leave that checkbox and we'll say finished.
Yeah, it took it.
It's there now.
Yes, it took it.
Interesting that it didn't show up. Did I click cancel or something? I've never seen that before. I tell you, I practiced this thing like, let's see if we can ping. Yeah, we can ping. There we go, it's full. That was weird. I haven't seen that. So something weird in my lab, but okay, it's up now. So if I do show route, you can see here some interesting things is there's my loopback address, right? Coming from ACI that I said advertise. But where's my 192, 168, whatever, right? Where's my bridge domain and my EPG silver and gold? Aha, there's a few more things that we need to do. So let's go back to our bridge domain. See, I've created a routing relationship with the outside world, but I need to tell ACI who has the right to consume this link, this path, right? It's not just everybody gets it by default. Remember, we're taking a very specific security approach. So if I go under the bridge domain A, under layer 3 configurations, there's a couple of things I need to do. The first is associate this layer 3 out to a given bridge domain. Let's say, for example, I have 100 bridge domains, but I only want 50 of them to use this internet link. Well, if they don't have the association, they can't use it. So by a matter of this association, now I'm telling the system that this bridge domain comprised of these networks may be able to use this layer 3 out. One more thing, look at the scope here. It says private to VRF for both of my primary and secondary. That means don't advertise the subnet. So in my imaginary policy, I want endpoints that are in the 1.1 network to get to the internet, but I don't want anyone in the 2.1 network, right, to get to the internet. I can be very clever and sophisticated with the policies about how things get to communicate if I want. So I click the box advertise externally and I'll say submit. And if we go back to my firewall and we look at the route again, we can see in just a minute, there's my 192.168, but not the other one. If I wanted that route, I would also mark it external, right? So that's good. So far we are good. So let's go back to this guy and let's ping Google's DNS server. And it's not working. And I did that on purpose, right? I swear to you, I did this one on purpose. What do we need? What are we missing, right? We have EPG Silver trying to talk to the internet, which is the external EPG. I need a contract, right? So here's my layer 3 out, my external EPG called everything, new name. I need to apply a contract. This is standard contract behavior. So I'm going to use a contract that comes out of the box called common default, which is basically permit everything because it's pretty easy. So I'm going to provide internet access through that contract. Go back to EPG. Now, I've got EPG Gold, I've got EPG Silver. They're on the same network, 1.1, right? One's 1.10, one's 1.11. In my environment, see, I want to get to the internet, which I'm Silver, but I don't want Chris to get to the internet. He's Gold. He's the user of Gold, right? So what I can do here is I can simply just apply the consumed side of that contract, common default, to only Silver but not Gold, right? And now if I go here and I try to ping Google, there we go. I mean, that's Google's real DNS server, so you're getting to the internet, right? So I wonder if my DNS server is working because I can. No, let's not do Cisco. That's too easy. Let's do apple.com. Yep, it's working. Internet's working. Let's go over here to Gold. And of course he can't ping the internet because my policy doesn't allow it. But look, they're on the same subnet. They're on the same bridge domain. Right, exactly. But they're different EPGs. And according to my desires, my policy, Silver can, Gold cannot, because that's how I want it, right? And that's how I've configured it. So with that being said, We've just configured at least the last part for me. So here we are at the end. So we have very quickly, in less than 3 hours, with a few minor hiccups, but user error, a fully functional SDN fabric with VXLAN overlay, full fabric secure discovery, housekeeping. We connected blades, we connected racks, we integrated hypervisors, we created tenants, VRFs, subnets, EPGs, contracts, and we got all of that stuff to, at least the parts that we wanted, to talk to the internet, right? So this is just what I would kind of call the basics of a functional ACI fabric, all in less than 3 hours. So there's a whole bunch more that I would have loved to show you, but we'd be here all night. But there is one more powerful topic that I want to leave you with today. What about automation? Because couldn't you have done that tremendously faster? Not all this clicking and UI and fat fingering. Well, Chris is going to show you, I hope within 15, 20 minutes, maybe we go a little bit longer, what is possible, or at least whet your appetite with what's possible with automation, because that's another topic that we could go very deep on given the time. So Chris, let me pass you the ball.
Yes. There's no coffee break.
There's no coffee break. You only get one for 3 hours, right?
That's right.
HR approved it.
That's correct. All right, so you should be seeing my screen any moment now.
Yes.
I'm in your fabric.
Oh no. You're going to automate my fabric.
And so, yeah, in the 15 minutes we have left, all I'm going to do is, as Joe said, I'm going to whet your appetite in terms of automation capabilities on ACI. We can literally talk about it for hours and hours, but I want to show you what is possible and give you some pointers for further exploration into the capabilities. So the cool thing is everything that you are looking at, absolutely everything here, the user interface, every single object, is the result of an interaction between the client and a REST API. So ACI is built around a REST API. So what does that mean? It means that there is a single programmatic interface to get in and out of ACI. In other words, to push configuration, you go through a REST API, and to retrieve information, you get also through that same API. So you can do GET request, you can do posts, and you can delete. So to give you a very specific example, imagine I want to go to the tenant's policy, and there's a description field over here. If I wanted to change that, what really happens, I can go here and invoke something called the API inspector. So if the font size is too small, somebody lets me know, but it should be okay. Right? So I'm going to call the API inspector. And what this is doing, it's a little sniffer tool that looks at what's happening between the client, which is really, not the browser, but the web application here, and the backend of ACI. So if I ask, show me all the posts operations. So in HTTP, post is a verb which allows you to modify the state of a resource. If I change the description here, for example, I am changing this field, and I click submit. Right, so now I have a new description. Well, if I go to my API inspector and I filter and highlight, what you have here is you can see exactly what happened. So my changing of this description entailed a series of actions. One is the URL. So as you can see, every resource in a REST system has a unique URL. So the tenant here has a location, which is called API, node, MO for manage object, uni for universe, that's the top of the tree structure. I'll explain that in a bit. And then TN for tenant acme.json. And what I do once I post to that location is this. I post a JSON payload, which affects the description of the tenant. All right. So if I wanted to do this myself programmatically, all I would have to do is simply write a script which would contain the URL like this and the description. And I could go to the description field and say something like, look, a script changed this, right? And then I would save that. And now imagine I am, oops, hold on a second. Imagine I am using an orchestrator of any kind, you see that this is changing now. So what I just did, you can do with any language you want. This is language agnostic. It's just the matter is posting the data at the right location. To find out the location, you can use the API inspector, and to find out what to post, you can simply look at what the inspector is giving you. So it's super, super simple to replicate something. So the API is using authentication. So you have to get a cookie, which you can see here. And then once you have the cookie, you can do get and post requests. So all this is doing is simply posting the payload in the file at that given URL. And I can just do this. Now, it gets much, much better. So you can really do a lot of things. So for example, imagine that, I don't know what Joe did. And I'm like, well, if I see this tenant, I don't know what I'm going to do with it. So I'm going to save it. And I'm going to delete it. So imagine I save the tenant. So configuration subtree means I want to get all the children, and then in JSON. So I download this. So I have this here, which I'm going to open. So I realize you guys don't see it because it's coming up. So I'm opening the tenant definition, and you'll see, let me just format this. Shift of F, I think. No, not this one, that one. I just want to make it look pretty in terms of JSON. So what you get here is the entire configuration for the tenant. So as you can see, it's a structured sequence of objects. So it's a JSON data structure. I have the tenant, and then I have the attributes. You can see the description, the name over there, and then the children. The contracts are here. Inside the contracts, I'm going to have some filters. Exactly the stuff that Joe created, right? All of this is here. You can see the L3 out is right there, the OSPF, the external EPG. Everything that Joe did today in the past 2 hours is stored as a structured block of data. Of course, what I can do is modify anything here, right? So imagine I want to do a duplicate of this thing, right? So tenant Acme 1. So maybe I want to change it to Acme 2, right? So what if I just change this? Well, I could simply do that and post, and I will have a duplicate tenant. So that would be super, super easy. So I can try that. I don't know if Acme is referred anywhere else in the file. So I'll do something else, which is a little less risky considering the time that we have. So I'm not going to touch that, but I want to show you something. So now that I have this, I'm going to delete the tenant, which is quite dramatic. The tenant is gone now. So I wasted 2 hours of work, really.
Where's my tenant? Oh,
it's
no.
gone. It's gone. So I can go here. I can click post. I remove the name of the tenant because I'm going to create a new one. I take the file name that Joe gave me, which is here, and I post. And within seconds, I have the tenant complete with everything that Joe configured. All right, so I look at the policy, and then look, I have my EPGs with the contract and the L3 out. So it's super, super easy. Now, of course, what you would do in reality, what most customers do is this. You would go to a higher level orchestrator. So one which is very popular is Ansible. And Ansible looks like this, right? In Ansible, I don't know if you have seen this before, but Ansible is a higher level language which has a series of modules. So here I have a list of variables. You see my bridge domains, my endpoint groups, my contracts, my filters, the contracts that each EPG provides or consumes, right? And then I have a series of tasks. So I have create the tenant, create the VRF, create the bridge domain, create the subnets, yada, yada, yada. A lot of things that are going to happen here. All I have to do is, watch this, I go to tenants and then keep an eye on this screen as I launch Ansible. Playbook, my inventory, full demo. So I'm starting this, and you see here a tenant called Webinar. and one VRF, 3 bridge domains, BD subnets, application profile, endpoint groups, associate EPG to the domain, creating the filters, filter entries, contracts, subjects, bind the filters with the contract, and then populate the contracts in the EPGs. We're done. I go look inside the webinar tenant, and then watch this. I have my application profile, which has 3 EPGs mapped to Joe's VMM domain with contracts, web and database. And if I look inside the EPGs, you can see that they're completely configured. They're ready basically to receive endpoints.
Right, I see them in my VM domain, so I could assign VMs right now and go to town in seconds.
Yeah. So it's complete here with everything that you need to get traffic going in production. All the contracts are there. The subjects are populated with the right ports. So you see HTTP. So it's super, super easy to automate. And this is one of the main motivations for people to deploy ACI. It's the ease with which you can automate mundane tasks or even complex tasks. I'm going to say 80% of customers are seduced by that because it's architected in the right way. There is a REST API and nothing else. And that REST API is super intuitive and very easy to use. And we have done, I think, a really powerful job at giving you automation capabilities for the platform. So you have 200 plus Ansible modules. There's a Terraform provider. There's 2 SDKs for Python. There is PyACI and the ACI toolkit. So that's right there, just 4 options for automating the fabric to suit your needs. And if you are curious about how this all works, what I would recommend is deploy a simulator VM, and the simulator VM will give you access to all of the automation that I just ran. You can actually look at the objects, modify them, post, get, and also on DevNet, on Cisco DevNet, you have sandboxes, code snippets, examples, classes, tutorials, everything that you might possibly require to get up to speed with automation, you will find it there. And that's pretty much all I can do in that.
Someone in the Q&A was asking, can you share some of these scripts or these playbooks? Don't we have like a Git repo or something that we have a lot of examples and
yes,
scripts and things people can
quite
start
a few
with?
There's quite a few on GitHub Data Center, I think. I don't know if I have them on mine. If I don't, then I will. I probably have them here, by the way. That's the open card. I need to push on that repo, so I'll push later today what I've been using on that one. I might have them somewhere else. Let me just check.
Right. While you're doing that, I mean, a few people were saying, like, where can I get Ansible? Where does it run? Well, I just want to be clear that Ansible is not owned by Cisco. It started life as an open source community. With a commercial side, if you wanted. It got purchased by Red Hat, so Red Hat owns Ansible, but it's still a free tool if you want the free version. It's basically, you don't get support, but you have full features. Or you can, say, pay Red Hat for commercial level support, and they can help you with all that stuff. But if you go to ansible.com, you will see that you can download versions for Linux, for Windows, for Mac OS, pretty much anything, right? So and it's a free tool, and it's very widely used, and so there's tons and tons of blogs, web pages, Stack Overflow questions of people who have gone before us that have sort of figured out how to do things well and can help add light to your Ansible journey. And Ansible is just one choice, right? I mean, you could use other tools as well, but Ansible seems to be quite popular. You're committing right now, I see, Chris. Okay,
Yeah,
he's committing the script for you guys on the fly. That's nice.
It's an existing repo, so it's going to complain for sure.
And Steve Sharman posted his own
Oh yes, Steve has a bunch
playbooks
of
to
stuff.
build everything. Yeah, he has a bunch of stuff. Yeah, so you know, what I like about this sort of open source community is there are so many other people who are openly sharing and helping, and it really makes it kind of fun and useful to get started very quickly.
Yeah, I'll push. I'm not going to waste your time now, so I'm going to push those scripts later today. And then Steve has a whole bunch of them as well.
Yeah, exactly. Yeah, he posted them in the Q&A. So
Yeah,
thanks, Steve.
I'm stuck with my proxies. I have to figure out the proxies, and then I'll push
Yeah,
stuff as well.
proxy, I know.
Okay, well, I think we're just on time. So I hope that was beneficial. I hope you got a lot out of this session. There's going to be much more content the rest of this week. As you know, tomorrow we are doing multi-pod, multi-site, which is extending ACI to multiple geolocations and doing regional or global high availability. And Max is going to lead that discussion. Wednesday, we have extension to the cloud and containers. So that's going to be myself and Domenico from my team. And on Thursday, we have day 2 with Matthias from my team. So we specialize also in day 2 tools. So we'll wrap up and see you tomorrow. I guess Federica, is it the same? Is the WebEx ready for tomorrow? Everybody has a link. Nothing to mention.
Yeah.
Same time, same
I send
place.
a reminder to everyone, the same time with another link, but everyone should have it. And the other thing that I want to share with the audience is that the slides are already in the box folder, but for the recording, it might take some 1 day, I think, to have the link, but I will upload as soon as I have it. And that's it on my side.
Perfect.
Okay.
All right.
And I'll upload my slides to that box folder too, in case anyone saw something that they liked.
Yeah. Thank you.
Perfect.
Okay. See you guys
All
tomorrow.
right.
Okay.
So thank you, Joe. Thank you to all the panelists, and thank you to all the attendees for sticking around. And we'll see you all tomorrow.
Thank you.
Goodbye.
You can end the recording.
You can end the recording and close the event. All right. Maybe we can stay for some Q&As. I guess they're all answered.
We had almost 500 people on this call, Chris.
I know. I was just checking the questions that are left. We're good. Are we out of the main session?